Additional Director who looks after finance. And we are going to, the whole idea of the World Solar Investment Summit is to bring the stakeholders together. And at the time of COVID, when we find that there is actually a lot of migration of capital from the sector, to bring it in. And as countries, put in more and more money to recover, to get that economy back on stage, back on foot, we would like more money to flow into the renewable energy sector so that the transition is sustainable. And it's a real transition, that the mankind wants to fight global warming. Having said that, coming back to the webinar, we have now, two very useful things. One is, of course, the webinar that we do a program linked one, and the general topics we cover called Solinar, the solar webinars. So it's more focused into technology issues. And today's program is dear to many. We are talking about storage. In an age when we are also talking about one sun, one world, one grid, combined with the World Solar Bank. So as you all know, the Assembly last time has formed an international steering committee to take this World Solar Bank. In fact, we have now got the list of ISA member countries who have very stressful situations so far as foreign debt is concerned. How do you pay back the money to the developers, the loans that you owe at a time when your resources are minimal? And taking those sensitivities into account, the e-mobility, which actually at a time when, it not only brings down pollution, it creates more employment, and it, of course, helps the environment. And World Solar Bank is, again, for the member countries, which will try to reduce the cost of capital further, and take into account that the countries who need the investment most get some dues. Although we get around $140 billion investment annually in the solar sector, we find that this is limited to a very few countries, around 22 countries. And we have right now 88 signatory countries. We have 70 countries where the ratifications have come through. And the first amendment, once it is through, you will find that all 193 or 94 member countries of the UN can be members of ISA. And that will be a day of pride to see that ISA has 194 all UN member countries as its members. And in the program fund, we have put 7 programs. Our StarC program is coming with the StarC project is coming with the help of UNIDO. We have got an operational infopedia. With the help of Defeat, we are going for a third version of the web page. We call the third edition. We had 2 so far. And in all fronts, we are starting, an ERP in the office. We have advertised for recruitment of 4 director level people in ISA, of which we request for more applications from all the continents. And we are going to soon advertise 12 more posts at UN level. And then, of course, we have 24 local recruitment, so that the secretariat becomes full. We are going for a resource mobilization drive of $100 million from 7 member countries, 7 non-member countries, 7 foundations, and 7 corporates. So in all said and done, we are really geared up to implement the programs. And this particular webinar that we're talking about today is to bring practice into theory. Usually you take theory into practice, but here we believe that we must stand hand to hand, shoulder to shoulder with the industry, and we must bring industry to the forefront. We must create a roadmap for the global industry, and that is the way to address the issues of 2 billion women who have no access to clean energy, or even 700 million people who are said to be left out at the end of 2030 without energy access. In this direction, Your Excellencies, our latest exercises, and 2 of them. One, we demand aggregation for solar pumps for 22 countries, brought down the price by 40%. And the present exercise of 9 million home power systems, every year 9 million, in 5 years we'll have around 45 to 47 million, combined with 5 bulbs for each system, which comes around 250 million LED bulbs. We are sure that the prices will come down, and this will actually bring the market to the people, to the poor people who actually cannot afford energy access today. With these words, I'm once again, thankful to my colleague who have put a lot of efforts to put this together, all my colleagues. And thank you for joining us. Thank you for joining us, and all the best for the seminar. I'm sorry I won't be able to continue, but what I'll do is I'll collect the video and I'll go through each minute of this. Thank you. Thank you all once again.
Thank you, sir. Thank you very much, DG sir. I would now request Mr. P.K. Mahapatra, Chair, ISA Project Committee and Regional Coordinator, LAC Region, to kindly set the context for today's webinar, please. Over to Mahapatra, sir, please.
Thank you, Mega. Respected Director General ISA, dignitaries and excellencies from various member countries, distinguished speakers, my ISA colleagues, participants, ladies and gentlemen. Good afternoon. Good morning to excellencies and friends in West Africa, Europe, North and South Americas. Good evening to excellencies from Far East, Australia, and the Pacific region. I welcome you all to today's webinar on e-mobility and storage being organized by the project group of the ISA. This is the fifth such webinar that is being organized in order to support knowledge dissemination and capacity building of ISA member countries. As my colleague Megha just informed, the earlier webinars in the series were focused on solar desalination plants for drinking water purposes, solar power efficient cold chains for increasing the post-harvest shelf life of fruits and vegetables, etc., ground-mounted and rooftop solar projects. The next webinar of the series is scheduled to be held on 10th December 2020, that is next Thursday, and that is will focus on the solarization of health centers, that is the primary health center, etc. Today's webinar is a platform for us for scaling up solar-based e-mobility storage projects in ISA member countries. The webinar will derive and delve on some key issues which are imperative to countries on multiple fronts, especially with respect to climate change adaptation and mitigation, scaling up of renewable energy and reducing air pollution and greenhouse gases. Based on today's experience, we plan to hold a sequel to today's webinar during the next summit in January. The Sustainable Development Goals adopted by United Nations General Assembly calls for sustainable transport systems along with universal access to affordable, reliable, sustainable, and modern energy services, quality and resilient infrastructure, and other policies that increase productive capacities and would bring strong economic foundation for all countries. The transport sector in this respect directly contributes to achievement of targets of 5 SDGs, namely SDG 3 on good health and well-being through reduction of emissions, SDG 7 on energy access through integration of energy efficiency in vehicle and through solar-based models, SDG 9 on industry, innovation and infrastructure, SDG 11 on sustainable cities and communities, and SDG 12 on ensuring sustainable consumption and protection. Urban mobility is rapidly becoming one of the greatest challenges facing developed and the developing countries alike. Transport is estimated to be responsible for nearly a quarter of global energy related to carbon dioxide emissions. There are also rising concerns about its impact on the quality of urban life, including social inequities, and about the effects of its pollution on health and buildings. The above concerns are indeed quite pressing. At a time when global emissions need to be going down, transport emissions are on the rise, with improvement in vehicle efficiency being more than offset by greater overall volume of travels. Electric vehicles have emerged as one of the key torchbearers to this continuing transport conundrum. Ambitious policy announcements have been critical in stimulating electric vehicle rollout in major vehicle markets in recent years. Although electric vehicles' emergence in the mobility space have been of recent origin, the concept of using electric vehicle as a medium of transport is not new. In 1832, Robert Anderson developed the first crude electric vehicle. Thereafter, in 1889, William Morrison demonstrated the first electric vehicle in the United States. This shows that electric vehicles as a concept have long been in place since more than 150 years. However, these early developments were quickly consigned to a footnote of history since the internal combustion engine grew in popularity far more rapidly in view of the limitations of the storage in battery technology. After entering the commercial markets in the first half of the decade, electric car sales have soared. Only about 17,000 electric cars were on the world's road in 2010, which has now swelled to 7.2 million in 2019 as per International Energy Agency estimates. The photoelectricity effect was known to the mankind even before Albert Einstein was awarded the Nobel Prize for Physics in the year 1921 for explaining the physics behind it. It took us more than 100 years to develop the technology to such an extent that solar photovehicle power today is cheaper than the fossil fuel-based electric generation. Interestingly, the trajectory of the electrical vehicle development and commercialization traces a similar path. The electric car sales in 2019 accounted for 2.6% of the global car sales and about 1% of global car stock, registering a 40% year-to-year increase, leading to an addition of about 2.1 million electric cars in 2019. As technological progress in electrification of three-wheelers, technological progress in electrification of two and three-wheelers, buses, trucks advances, the market for them grows. Electric vehicles are expanding significantly. A lot of business models have emerged since then for sustainably developing and deploying electric vehicles on ground and for encouraging citizens to adopt electric vehicles. In 2019, indications of continuing shift from direct subsidy to policy approaches that rely more on regulatory and other structural measures, including zero-emission vehicles, mandates, and fuel economy standards, have set clear long-term signals to the auto industry and consumers that support the transition in economically sustainable manner for governments. More recently, efforts have been on integrating solar with electrical vehicles, especially with regard to solar power charging and facilitating vehicle-to-grid and grid-to-vehicle integration. The business models include public charging, solar-powered electric vehicle charging corridors, solar off-grid EV solutions, solar charging combined with battery swapping, and plug-and-play systems. Many of the automakers now EV manufacturers are themselves taking a lead in piloting such initiative. A case in the point is that of RoboBank, which along with SolarCity have created a solar power enhanced electrical vehicle fast charging corridors along with Highway 101 in California. While RoboBank provides the parking spaces in its parking lots along the 101, SolarCity provides the power courtesy of a bank of solar panels mounted on the roof of each participating branch. Apart from providing green electricity for the electrical vehicle chargers at the branches, the solar panels will also provide power to each branch. Batteries, as we all know, is not only a critical component, but also a critical driver in enabling electric vehicle deployments. Batteries contribute around 40 to 50% of the cost of the vehicles, and technology development in batteries and storage space would have a major implication on the cost of electrical vehicles in future. The cost of lithium-ion battery, which is one of the most widely used battery chemistries, have plummeted up from US $1183 per kilowatt hour in 2010 to US $156 only per kilowatt hour in 2019. This is likely to go down even further to below US $100 per kilowatt hour levels by 2023, as per an estimate from IHS Markit. Just like electric vehicles, batteries for storage have been in use for long. Batteries are so ubiquitous in our everyday life that they're almost invisible to us. Every time we go out, we either drive a car or take a public vehicles. We use remote control to switch channels and watching televisions. We unconsciously use batteries in our everyday life. They are used to power phones, remote controls, flashlights, hearing aids, and also providing starter ignition to our cars. Stationary battery energy storage systems are used for smoothing the demand and supply around the power generated from variable energy sources, particularly renewables. It ensures that electricity is available when the generation of the renewables is not available. In a world increasingly anxious about the climate change, the surge in generation of renewable energy over the past 20 years seems to be just a tipping point of the larger train. The variable nature of wind and solar power means that storing energy is emerging as the next big challenge. Large-scale battery installations are springing across electricity grids around the world to make them more flexible. In UK, battery installations are primarily being deployed to supply services to national grid. Such ancillary services are increasingly important to meet the supply and demand as growing amount of intermittent wind and solar power comes online. There are also beginning of hybrid renewable energy plants where batteries are installed alongside solar farms and wind farms. I'm told that in Australia, batteries are being used to make the grid more resilient and to avoid blackouts. Tesla popularized the concept of home batteries, which are about the size of a gas boiler and can store and release electricity, either generated by the household or imported from the grid. Such has been the importance of the development of battery space that in 2019, the Nobel Prize in Chemistry was awarded to John B. Goodenough and Mr. Stanley Whittingham and Akira Yoshino for development of lithium-ion batteries. The opportunities in both electric vehicles and storage space is immense, with wide multitude of applications and potential. Both these technologies need to be focused in order to aid in our green recovery of economies. This webinar will help set up a foundation base and platform for discussing some of the key pressing issues impeding the development of electric vehicles and storage. We'll also get to hear about some of the key technology as well as business models adopted by various companies. I'm sure that through the experience and insight by various speakers, we all will be able to understand and appreciate the entire ecosystem and need surrounding e-mobility and storage. ISA on its part is also keen to support the deployment of such projects on ground in various member countries. Some of the issues brought today will also be taken forward by ISA as part of its program on scaling solar-based e-mobility and storage. With this, I would like to invite my colleague, Dr. Philippe Malbranche, to give an overview of ISA's program on storage and mobility, e-mobility. Thereafter, I would request Megha to give the floor to our distinguished speakers, panelists, to share their thoughts. Dhanyabad. Thank you. Gracias. Marciatos.
Thank you, sir. Excellencies, as you are already aware that ISA has a program on scaling solar e-mobility and storage, the ISA Secretariat is committed to assist the member countries in expediting its implementation. I would now request Dr. Philippe Malbranche, Director Program 2, ISA, to present an overview of the ISA's program on storage and e-mobility. Over to Mr. Malbranche, please.
Thank you, Megha. Good morning, good afternoon, or good evening, depending on where you are. Et un bonjour particulier à mes collègues francophones. I'm honored and pleased to introduce you to this ISA 5th program on e-mobility and storage. Is my screen visible now?
Yes, Mr.
Yeah, please go ahead, yeah.
Okay. excuse me, I can change. Okay, now I can change the slide. You know, we are really working on fighting the climate crisis. Energy, I already used this graph to introduce our heating and cooling program. It's to show that energy is the key factor of greenhouse gas emission. I will not go further. Most of you are aware of that. But within the field of energy, we are very often talking about electricity, power, and looking at worldwide energy consumption. Power, electricity, represent less than 1/5 of the global energy consumption. You see that 1/3 is related to transportation, and half of worldwide consumption is related to heating and cooling application, whether for residential use or industrial processes. So integrating PV into the power electricity system or into off-grid system is important, of course. But you see that there's a huge space also in the transportation sector. And then going on the right-hand side, you see that so far power is still produced with 70 to 80% of fossil fuel, a big greenhouse gas emitter. And for transportation sector, it's even worse. It's 97 to 98% based on fossil fuel. So there's a huge place for decarbonization of this sector. And we will see that PV is not the only solution, but it's clearly a huge part of the solution. And why? Why that? There's a huge synergy, there's a perfect synergy between electric vehicle and photovoltaics. In terms of area, there's a lot of area available. Just considering parking lots, carports, along the road, you have plenty of area which are non-used. Also in many buildings, in all the built environment, there are a lot of locations in which to insert solar array. And also in terms an electric vehicle is sometimes connected to the grid, and then it can bring services to this grid. You know, through smart charging station, it can provide some grid support. This is what we call vehicle to grid, vehicle to building, vehicle to home in some places. And when it is connected, these vehicles can represent a huge amount of storage, which may help in managing the grid. So that's some of the synergy which exists between solar energy, development of solar energy, and development of EVs. Regarding the area, to me, it's really impressive to see that only 1 square meter of PV panel provide you with 100 or 200 of kilowatt-hour per year. In France, it's just an example. In France, it's enough to drive 1,000 kilometers a year. In Africa, in plenty of sun-blessed country, it will be 2,000 kilometers per year with only 1 square meter. So it means that for an average annual distance that a car has to be driven, it's a range of 10 square meter, 15, 20 square meter, which is enough to drive 20, 30,000 kilometers a year. So that's why it's really relevant. And it's especially relevant because this operating cost due to the low cost of electricity and the high efficiency of electric motor, you end up with operating cost in the range of €1 or €1 per 100 kilometers for a car. For a two-wheeler, three-wheeler, it will be even cheaper. So we will see this example a bit later. So coming back to solar e-mobility, because ISA cannot be in charge of all the development of electric vehicles as such, or all charging stations. ISA, as his name stands for, can be involved regarding the solar contribution to this e-mobility. So how could it happen? There are two scope, to my opinion, there are two main scopes of activities. First one is about solar integration within solar carports, within solar charging stations, which are designed to prioritize the supply of solar energy to the electric vehicles. And this solar charging station could be grid connected or standalone. And also, when they are, of course, when they are grid connected, they can provide grid services. So that's the first scope of activity. And here are some examples. In a previous organization I was working for, we developed this 10 years ago now. It's one of the first carports at that time, and we had 20 charging stations in operation since then. And now it's commercial. I just took two examples, one in India, one in France. It's about these carports. The beauty of that is that you mutualize the cost of grid connection. At the same time, you are connected to the grid, your charging station, and the PV array. So it's not twice the operation of grid connection, for once the PV plant and second the charging station. You can mutualize when you have a project. At the same time, you are getting grid connected, and then you connect your single or multiple charging station and the PV array. And this is, as you know, the cost of PV is decreasing, cost of grid connection, the share of grid connection becomes more and more important. So it's a way to mutualize this cost and to decrease the cost of the overall service to the end user. It could be, we could maintain this grid connection cost as low as possible by managing the grid connection using some storage. If you want to have a high-speed charging station able to charge with 50 kilowatt, 80 kilowatt for high-speed charging station, you are not obliged to have a high-power grid connection. If you have some battery, some storage system included into your carport, and this is what is represented here, it's one example which is in operation. It could also be charging stations which are not even grid connected. If you have a storage large enough, you may have standalone solar charging station. Second scope of activity is about the direct integration of solar vehicles, of the solar within the vehicles. So whether it's a two-wheel, three-wheel, four-wheel, it's a car, or more. It could be bus, trucks, and so on. It could be even boats, planes. I will show very quickly a few examples of two or three-wheelers. You just extend the possible range per day. So this were for bicycle, for cars. You have now several suppliers working on this. One of the most famous and the most advanced is Toyota, but there are purely developed vehicles to integrate as much PV as possible on the roof, almost everywhere. The challenge is to integrate several square meters of PV module in the body of the car. And yes, last example could be trucks, buses, and of course, plane. This one, Solar Impulse, was famous all around the world, but also on the sea, on the river. One example in India, in Bangladesh, for ferry, integrating solar PV on the roof. Few figures regarding what it could mean. It's not, this market is not going to be marginal at all. As I said, for any people having an EV, having 10 square meters of PV module, it's quite easy, or it can be made easy for some people. So of course, PV will have a strong growth as it is now in the power sector. So this is for sure. But what could this PV demand represent for the future? This demand from the transportation sector. There are simulations, hourly simulation, which have been showing that it could represent the same amount. In this case, 19 terawatt by 2050 versus 22 for the power sector. So it's going to be really the big thing. And on the diagram, on the bottom, on the right and the bottom, you will see that the growth of the power of this power demand for the transportation sector will be slower at the beginning, just because EV still do not exist, or the growth, the main growth is still to come. But from the year 2030 onwards, the growth will be larger in this sector than even in the power sector. That's not in our scope today, but it will be the same for the PV, for the industry through the hydrogen production. This will also represent something in the range of 20 terawatt. So just to give some rough idea, it will be 1/3 for what we call the power sector today. It could be 1/3 more for, in addition, for the transportation sector, for the decarbonation of the transportation sector, and an additional 1/3 for the industrial sector. All of this will be grid connected, so it will be a big growth in the power capacity. I'm getting out of time, so I'm going to speed up a little bit. So this is the explanation of the modeling which was made by this university. In our case on e-mobility, so we will start with case studies. We are now collecting case studies on this solar e-mobility. And then when we will have collected enough of them, we will be able to produce guidelines and to help in the setting up of projects. This is an example of one case study on solar motorbikes in Uganda. So solar, in that case, is sold as a service for taxi driver. Of course, we have to talk a little bit about storage. 10 minutes to cover everything on storage is a real challenge. Of course, storage is needed. We know it since a long time for off-grid services. So solar lanterns, solar home system, etc. Of course, by definition, you need storage. For bigger system, for mini grids using hybrid system, when you want to increase PV penetration ratio, you know, when you have a diesel genset plus a PV array, when you want to increase the PV share in the global energy supply, you need to add at some times electrochemical batteries. So that was the main use of storage systems so far. But now, due to the decreasing cost storage systems. And Mr. Mahapatra was giving us some few figures on that. We can now think of grid-connected services for two main market segments: residential application for safety use, or increasing the self-consumption ratio, or also it's becoming more and more common now, at least on the demonstration stage, for large-scale storage application. And with that, you can smooth or prevent the PV fluctuation to be seen from the grid. And of course, you increase the grid flexibility. Flexibility is a big issue regarding grid integration due to the intermittency of renewables. So with storage, you can do some peak power, solar peak power shaving, but also organize or manage some load shifting. Or if you have some flexible load to organize some curtailment. I'm thinking of cooling unit, desalination unit, or electrolyzer, etc. This can be curtailed anytime without any problem for the user. So that's going to be a big thing. And some of the grid services that can be provided are voltage regulation or frequency regulation. And of course, the big goal is to aim at round-the-clock services. This will require much larger, even larger size of storage systems. But due to the decreasing cost of most of the solution, this becomes more and more feasible. What can be used technology-wise, of course, we are always thinking of electrochemical batteries, but in some case for big application and more in the future, it will be pumped hydro. And when I say more and more in the future, it will be hydrogen, as long as it will be produced with solar or wind. Hydrogen will be the big thing for making grid integration easier. With that, yes, I have to speed up. This is the use of pumped hydro. Also for storage system, we'll have the same approach with case study, guidelines, recommendations, and then to support project, implementation of project. With this general overview, now I thank you for your attention, and I wish you a nice meeting with many more examples to come. Thank you.
Thank you, Mr. Malebranche. That was really insightful. Growth in e-vehicles is leading to advancements in e-vehicles charging infrastructure and energy management practices, leading to transformation in mobility experience. Effortless charging is going to ensure how people and goods will move in future and will contribute to the health of the planet. The idea is to create solutions that create a sustainable and caring future for people, environment, and the planet. Our next speaker of the day, Mr. Merkel Ramanath, Head of Accounts Management, Siemens, would be putting the spotlight on scaling, challenges, and solutions with their experience in e-mobility charging in Europe. Over to Mr. Merkel, please.
Thank you, Mega. I hope I'm audible. Let me also, just for the introduction, share the video. My internet connection is a little bit weak today in this webinar, so only for the introduction, I would keep the video on. After that, when I go over to the slides, I would turn it off just to make sure that there is no interruption in the line. I hope that is okay for you. Let me share my screen that we have a look at the slides. For the timing, I believe also I'm at the 20-minute threshold, so that should be fine. Mega, if you could quickly confirm that you see my slides?
Yes, please. Yes, Mr. Merkel, you can carry on, please.
Okay, thank you. Thank you very much. Yes, introduction. I am from the Siemens company. We are, or where I'm from, we are focusing on the e-mobility charging. And this is the topic where I would like to provide a little bit of a deeper insight today to you for better understanding what the challenges are when it comes to e-mobility charging and what the possible solutions could be that solar and battery storage could provide. Because for obvious reasons, I think there are a lot of synergies, and this is what we have also already heard by my speaker before, Mr. Malbranche. So being or focusing on the European market and the European surrounding, the European Union itself formulated the target to be the first continent in the world to be climate neutral. And that goal is to be reached by the year 2050. And that means that we have a lot to do, but also that we are very, very dedicated on the topic of climate neutrality, climate change, and obviously reduction of greenhouse gas emissions. What does it really mean? So already by 2030, within the next 10 years, we want to reduce our greenhouse gas emissions by half compared to the year 1990, which will already be a very, very strong activity required. In order to do so, that will take quite some investments. The European Union is planning or considering somewhat in the range of 100 billion euros to be invested until the year of 2027 already, to make sure that we are on a good path forward to reach that goal of climate neutrality. And also the last number here from this slide, the transportation sector, which has a great share of greenhouse gas emissions today, needs to be reduced as well from these emissions by 90% until 2050. We have already seen the numbers on the global view in the slides before. Now, this is the very specific view on the situation in Europe. On the left-hand side, 1/4 of greenhouse gas emissions today is coming from the transportation sector. If we take a little bit of a closer look on the right-hand side, all of the transportation, more than 70% actually come from the road transport. So that is a very big lever. If we are able to reduce this, it will already have a great impact on the overall greenhouse gas emissions. Now, the European Union is putting many measures into place. That is, on one hand, subsidies to make it more attractive to bring in or to introduce alternative driven vehicles, mainly battery electric vehicles. On the other hand, there will be penalties in case certain targets are not being met. And there will be funding available for projects and for the switch over to this change in the transport sector. And all this coming from the European Union, then this is broken down on the country level, on the national level. So Germany, for example, they just on last week, Friday, introduced a new guideline that 75% of all gas stations need to have at least one unit of 150 kilowatt fast charger installed until the year of 2026, which is also quite significant. Now, with all these measures in the background, we can see here on the right-hand side this exponentially growth or expected growth of e-mobilities or e-vehicles in the market. Just comparing the two extreme numbers, approximately 2 million units of vehicles in 2020, and then the expected or forecasted 31 million, which is roughly a factor of 15. Now that is really a explosion in the market. That will be a very big change. But behind these numbers, well, obviously it's not only that we need the cars or the vehicles, that we need the chargers, but we do need the energy behind it. I guess this is really what needs to be considered, and that will be some type of bottleneck that we are already experiencing today in our projects. Now, when we look at the European road transportation, in Europe, we talk about the cars that need to be electrified. We talk about the buses to be electrified, and we talk about the transport of goods in terms of vans or trucks for the electrification. Before we saw the pictures of the three-wheelers or of the two-wheelers, that is something that is really a minor topic in Europe, where we do not really see big numbers on the streets, and therefore also this is something not very much to be considered in these overall concepts and considerations. Now, in order to charge these vehicles, we have two different modes of charging. It's either the direct connection to an AC network, where you provide AC current into the vehicle, and then the transversion is happening on the vehicle from AC current into DC current, that the batteries running on DC can actually be charged. This is a very, let's say, simple solution on the charging side. It's very less cost, and it used to be the type of technology that was used in the beginning of this approach. Now, but this means that you can only transfer rather small amounts of power into the vehicle, which again results in a rather long charging time. So if you have a rather small battery, for example, on a car, a Tesla Model 3 comes with a battery of 50 kilowatt hours. A Tesla Model S comes with a battery of 100 kilowatt hours. That is already, let's say, some time that you need to consider. If you go into bigger battery packs that you, for example, see on buses or on trucks, where you see maybe around 300 kilowatt hours on the battery or even more, well, this results in quite long charging times. That's why if time is an issue, it's beneficial to choose another technology, the DC charging, to reduce these times, because here we can transfer very much higher power ratings and therefore reduce the timing. If we use a cable that we connect to the vehicle, we can go up to 150 kilowatts charging power with the DC, with a standard cable, or now quite new in the market, we see cables that are liquid cooled, that can carry currents up to 500 amps, which then results in power ratings, depending on the voltage level of the battery, above 300 kilowatts. And now this is really significant and really reduces the amount of charging time required. For the electric buses, there's even more possibilities to connect the vehicle. We have fully automated systems with the so-called pantograph. And here we can achieve charging currents up to 850 amps, which then results in charging powers of 600 kilowatts. That really enables you to have the charging in a very short time, to make sure that the vehicle is up and running most of the time and doesn't waste time being charged and connected to the grid. Now, what does it mean in real life? Where do we see these different types of chargers being deployed in the city, in our environment, in the landscape? Now here, our typical city, if we look for example, at the e-car charging. Mainly today, the AC charging, this can either happen here on the very left-hand side at your job site, the office buildings. People come in the morning, they park their car, go to work for 8 hours. Car is plugged in for the time being, and then after work, they leave again. So in this example, rather small parking lot, maybe with 11 kilowatt power rating chargers being installed. Here, if we had 20 vehicles charging at the same time, this would result in a total power demand of 220 kilowatts, which is something that is certainly not too difficult to achieve with the modern grids available. In the center, also possible when we have the inner city parking, maybe at shopping malls or at other places, movie theaters. Here, the time where the vehicles are connected could be a little bit shorter. So maybe the power rating is chosen a little bit higher, for example, 22 kilowatts, which is basically the maximum you can achieve with the AC charging. If we then want to electrify, let's say 20 parking spots, or we have 20 cars charge in parallel at the same time with full power, that would result in a total power demand of 440 kilowatts for this specific site. And then, of course, we have the residential charging on the right-hand side, where the vehicles will be mainly plugged in over nighttime. And then again, we have longer times available, so the charging power can be less, but maybe we have a bigger quantity of chargers being installed, then again resulting in a certain amount of total power demand from the grid, certain grid connection. Now this changes if we want to repower the car, the battery that is running electrically, similar to how we do it today at a gas station. So we pull into the gas station, we connect the vehicle, and then we transfer the energy in a very short time. We want to do that in a few minutes, maybe 15 minutes, 20 minutes at the maximum. This is reached by high power or ultra high power chargers. First developments are coming up where the cars can accept 300 kilowatts actually charging power. Today, common or the first vehicles are more at the 150 kilowatt rating, but that will change in the future. So here, all of a sudden, we see very high power demands for the grid that needs to be considered already in the megawatt range. And this will even increase when we talk about electrification of entire fleets. Now, this could be either your bus fleet that is shown here on the very left-hand side, where you can have easily 100 vehicles in one depot, and then they all need to be charged overnight in a time frame of maybe 5 hours, because then the first buses need to leave again. That would result in a power demand, total power demand of 15 megawatts already to be supplied during nighttime. And we would have a similar situation if we talk about vans or trucks here for the logistics companies that we see here in the center. Also, power ratings for the chargers, 150 kilowatts is common today. And then depending on the amount of vehicles that we have in this depot, we see the total power demand for the installation itself. But also bigger quantities of AC chargers for the cars. If we have a whole parking garage, for example, and we have many vehicles being connected, charging at full power 22 kilowatt through AC, also this can already result in the megawatt range of grid connection. Now, obviously, this needs to be assured and this needs to be provided. Now, most of these installations, if we look at logistics depots or if we look at bus depots specifically, they were never designed to charge electric vehicles. So the grid connection that we find is more in a range of 200 kilowatt, but we need 15 megawatt. And this is where really new ideas, new solutions need to come into place. And where definitely alternative energy generation and probably in combination with the battery storage can really enable these projects and make sure that they're at all feasible to change over to electrification. Looking a little bit into the future, what do we need to expect? What is coming up? Also, the long-haul transport of trucks and goods is in the preparation for electrification. We have the discussion, would it be rather battery electric transport, or should we rather consider hydrogen technology on these long-haul trucks? I believe it will be a 50-50 situation that we should expect in the future. There will be use cases for the batteries and there will be other use cases for the hydrogen. But I do not believe that there will be a solution, a one-fits-all solution that we will see in the future. So when we talk about the battery electric trucking, we are currently in discussions and standardization of the so-called Megawatt Charging itself, where power ratings of up to 4.5 megawatts per charge point should be provided. That would result, or that would mean 3,000 amps charging current at 1,500 volts. And this obviously has very certain requirements on the technology itself. So what we can see here in the background, the vehicle most likely would be connected with an automated charging arm to make sure these kinds of power ratings can be handled safely. And then in the background, to run these kinds of recharging stations, most likely battery storage would always be required. And then here we see this decentralized AC-DC conversion, so that only the DC current is then already fed towards this automated charging arm and into the vehicle itself. Now to summarize the few slides that I've just went through. So the grid connection itself is one of the main challenges that we see today when we talk about fleet electrification or entire depot electrification. So here additional local battery storage can definitely help, or any kind of additional generation. It might not be suitable to electrify the whole demand, but already if part of it can be reduced through additional generation, for example, with solar, that will definitely be of help. Now, what is to be expected in the future? The year 2030 will be a threshold year in Europe. After that, we do not expect any more buses to be sold with combustion engines, and we expect the majority of cars to be electric that are being sold after 2030, and also the trucks for the heavy-duty transportation will be shifting over to battery electric as well. The vans will be leading, and the trucks will be following. We already have cities that are putting out restrictions for combustion engine trucks that are not allowed to enter the city anymore after the year 2025. So this is really coming up. Another topic that needs to be considered is the autonomous driving, a technology that is going hand in hand with the electrification of the vehicles. And this will also have a big impact on the charging behavior, as the driver might not need to stand next to the vehicle while it's charging. Maybe the vehicle can do that independently. So whole new charging concepts might come up in the future as well, having new requirements on the grid connection and on the power supply itself. And then obviously Siemens as a company, as a partner, we provide today all the solutions that are required for electrification, and we will provide the solutions for the future as well. Having this said, I would come to an end with my presentation. If there are any questions, my contact details are provided. Please feel free to reach out. And I think also the slides will be shared after the event. Thank you very much for the opportunity, and please enjoy the rest of the webinar.
Thank you, Mr. Merkel. Thank you for this very well-rounded presentation. You not only gave us insight into policy and regulatory framework driving the adoption of EVs in the EU, but also gave us an insight into how to transfer energy into battery in different circumstances. With innovative interventions like automated charging arms, I'm sure the future is going to open more options for megawatt charging and interesting topics like change behavior for the charging station, people working in charging station. With this, we move on to our next presentation. Our next speaker for today is Mr. Rahul Walwalkar, President, India Energy Storage Alliance, Chair, Global Energy Storage Alliance, and President and MD, Customized Energy Solutions, India. India Energy Storage Alliance focuses on the advancements of energy storage and e-mobility technologies in India. Their members encompass energy storage manufacturers, research institutions, RE power electronics, and EV manufacturing companies. Mr. Walwalkar would be sharing a global perspective on role of energy storage and RE integration to the August gathering. Over to Mr. Walwalkar, please.
Thank you very much, Megha, and thank you very much to ISA for organizing this very important webinar and bringing together all the thought leaders to talk about energy storage and e-mobility. So just to give background, so as it was mentioned in the introduction, I'm President and Managing Director for Customized Energy Solutions India, which is a global energy consulting and services firm. We have been working in energy storage since 2004, and we manage more than 10 gigawatt of assets across the world, which includes more than 300 megawatt of energy storage assets as well. So some of the insights what I'm sharing today is based on that practical experience. So why we need to talk about storage, and again, some of the previous speakers have said the background, so I'll go through some of these earlier slides a little bit fast. But as we are seeing more and more solar and wind being deployed, one of the challenges which is happening is the time availability of these natural resources does not necessarily match the load. So there has been thought that, okay, if we add solar and wind together, then wind is more usually available at night or early in the morning, and sun is available during the day. So that complements each other, but still it is not exactly. When you start looking at on a day-by-day variations, then you are going to have a situation when you just do wind solar hybrid, there will be some hours where both wind and solar is there available and you have much more energy than the load. And then particularly in the evening hours, especially beyond 3 p.m. until maybe 9 p.m. till the wind picks up, you are going to have time where both solar and wind energy is not matching with the load. And that's the area where energy storage can come in. If you just keep on building more solar or more wind, then you are going to face very significant curtailments, as well as the investments which you have to make for transmission and distribution capacity are also substantially higher. So from overall system economics point of view, solar plus wind plus storage makes a perfect sense. Now, you need to see how this storage is accommodated, and is this something only for one or two developed countries? Here is the chart shows the some of the projections in terms of the growth of renewable energy for many different countries, and through the efforts of ISA and similar agencies, we expect actually we are reaching a point where we can be looking at much higher penetration of these renewable resources if we can manage the grid reliability and associated challenges. So you can see that many of the regions are looking at having anywhere from 40% to possibly even 80% of the energy coming in from renewables when you account for hydro. But even out of that, a majority of the renewable energy is expected from solar and wind. So this is again something where we definitely need to look at the dispatchability of the renewable energy and try to optimize that. Now, when it comes to energy storage, there is a lot of discussion about batteries, and obviously lithium-ion batteries have become a very strong area of interest around the globe. But as an energy storage, there are many technologies, as it was mentioned by one of the initial speakers. Electric vehicles also bring a lot of the storage available on the grid. And if you can have smart charging infrastructure, if you can plan the infrastructure in a certain way, then all these storage available on the e-mobility sector can become a significant asset for the grid. But if not, and if you just end up looking at this as a one-way transaction where you just need to build more grid capacity for just meeting the demand from these electric vehicles, then actually you end up facing much tougher challenge in terms of building the grid and planning the grid. But overall, apart from the batteries, there are other technologies such as flywheels as a mechanical systems or compressed air energy storage, pumped hydro. There are thermal storage technologies. There are other modern gravitational storage technologies which are non-hydro, which are being designed. There are chemical technologies such as fuel cells, electrolyzers, ultra capacitors as a purely electrical storage technology. So all these technologies are getting commercialized, and depending on the applications and how the regulatory environments in different regions pick up, you will see multiple technologies will find its opportunities in the commercial world. Now, one of the key areas is the reason why we are seeing such a strong interest is, as we have seen with solar during the past decade, energy storage also has witnessed tremendous drop in prices. Back in 2010, lithium-ion batteries were costing more than $1,000 per kilowatt hour, whereas now in 2020 they have come down to almost around $120 per kilowatt hour. And part of this reason is the technological improvement, but the other part is also about scaling up of manufacturing. Right now, around the world, there is around 400 gigawatt hour of annual production capacity, and in next 5 years, it is expected to increase another 5x. So we are not reached sort of the plateau of some of these improvements, both in terms of the technological improvements as well as the manufacturing scale up and manufacturing improvement. And we do expect that this price trend will continue, and we will start getting somewhere between $60 to $80 of cell prices within next 5 years. But this is not only about lithium-ion batteries because of the investments happening. This is something which is most talked about, but many other forms of technologies like vanadium redox batteries or other forms of flow batteries with zinc bromide, metal air batteries, all trying to improve on performance and try to reduce the cost. So this is something which is going to be quite exciting decade for energy storage industry. Now, in terms of the applications, energy storage technologies fit in across the grid, right from as a centralized resource where now people are building gigawatt hour scale storage assets. Again, traditionally pumped hydro has served that purpose, but even now with lithium-ion batteries or other forms of flow batteries, there are developers who are building gigawatt hour scale storage systems, which can be seen as a central resource for managing grid frequency, to providing flexible ramping, providing black start, as well as doing peak shifting for the grid. We can also use these assets for optimizing transmission and distribution investment, because especially as we are seeing that renewable energy resources are typically concentrated in certain geographical areas. And if you really want to tap into the right geological zones where renewable energy is available, you may need to significantly expand your transmission capacity. And there are a number of studies which suggest that the top 20% of the transmission capacity will get utilized less than 10% of the time. So this is some decision which I think as a policymaker and as a planner you need to make, is do we want to just overbuild transmission capacity and wait for 5-10 years for load to growth or the renewable capacity to come up, and then even at end of it you want to sort of leave top 25% of the capacity to be used only for 5%, 10% of the year? Or do you want to actually use technologies like energy storage and some of the changes happening on the control side, on the demand response side, to try to optimize your grid deployments in a more systematic way and more efficient way? The renewable integration is another key application. As I talked about in my initial slides, the wind and solar availability does not necessarily match the renewable. And there are many issues such as the ramp rate control, frequency control, where energy storage can actually complement these resources very well and actually remove some of the limitations of these resources and enable us to move towards significantly higher than 50% of renewable as a part of the grid resources. Microgrids is another area, particularly when you look at some of the remote areas, even in the developed countries, or especially places like Africa or in some remote regions of India, microgrids can play a key role. And this is the area where just grid expansion is not going to be a solution. Even if you can reach a grid expansion for meeting sort of the basic requirement of some of these remote locations, we have found out, even from example of India, that many of these remote locations do not have the right power quality where you can build economic activities around these weaker grids. So in such cases, actually having supplementing these existing distribution systems with microgrids can be a very good solutions. And this is not only for remote locations, but we are even seeing campus microgrids as one of the biggest growth areas where people are looking at increasing better utilization of distributed renewable resources, at the same time have better resiliency so that in case of any natural or man-made disaster, you are not left just using diesel generators as a backup option. Now, one choice which all of you need to make is there are very strong advocacy efforts done by existing fossil fuel industry and many of the companies who have right now their business dependent on this, that, oh, we should just keep on using thermal resources for balancing renewables. But this is the area where there is a significant now new research coming in that if you start using just thermal powers to balance wind and solar, then you can technically possibly achieve it, but you will lose significant benefits of the environmental benefits which are coming in from renewable resources by relying on thermal generation for these. These because of lowered efficiency. These include because when you are operating thermal plants at partial load, you have significantly higher sulfur dioxide and nitrogen oxide emissions from it. Sorry, I'm getting a background noise. So whoever is speaking, can you mute?
All the attendees, please switch off their mics.
Yeah, thank you. So instead of just doing that, there is a better solution available where you can actually deploy fast response storage technologies, and the amount of resources required for balancing renewables can also be optimized, and you can actually get end-to-end clean renewable power. And this is something which is even more amazing is that as the cost for these storage technologies have come down, now renewables plus storage is becoming actually cheaper than building a new thermal plant for managing these renewable resources. So maybe whatever thermal plants are available right now, if they are in a good operating condition, you can continue using, but definitely you need to take a very hard look at financing any new thermal power plants in your region, because especially with the prices of solar and now with solar plus storage as a hybrid prices coming down, there is definitely a better alternative available for all of you. Now, when you look at integrating storage with renewable energy, depending on different applications, you may need sort of a different size of storage or different duration of storage. And also you need to understand that the typical depth of discharge, like how many times the batteries or storage devices will get charged and discharged varies. So when you choose the technologies for different application, you need to have a very good understanding of these application requirements and choose the technologies appropriately. So that's where many times people just ask me that is there only one single solution available for technologies? And many people do believe that yes, only one technology can be a winner. But we are seeing, at least based on our analysis, that still there are opportunities available for multiple technologies for coexisting in this ecosystem. Now coming to the numbers, when you look at the cost of solar plus storage, typically people get scared because they just look at the marginal cost of storage only and think that, oh, we have to wait for another 5 years or 10 years before we integrate RE plus storage. But what people do not realize is that when you are calculating a blended tariff of solar plus storage or wind plus storage or solar plus wind plus storage, the price points are already becoming very, very attractive. So we are seeing these prices in terms of the Indian rupees, but even you can get a calculation by dividing these numbers by around 70 by converting it into the US dollars. You can see that especially going beyond 2022, the price points are very attractive, particularly for longer duration, which is around 4 hours of storage. And when you do that, it is definitely a good choice for both grid as well as for commercial and industrial customers. And just as a comparison on the right hand side, I have kept the price points for alternate technologies. And again, some of these technologies, you may argue that just the low price points are significantly lower than these. But since these resources like wind and solar are just not available when you need, that average price point being lower does not really help. You need to have that flexibility so that you can have dispatchable resources. And in terms of the dispatchable generation, be it hydro, be it gas, be it coal, you can see that the average numbers for all these resources are now becoming higher than the blended tariff of RE plus storage. So that's where it is not a competition between storage and renewables, but storage and renewables together can actually offset significant part of the thermal generation. Now, when it comes to the commercial industrial customers, there are many customers, and these are just daily load profiles. You can notice that they have their load shapes which are changing very rapidly. And if you want to start adding significant part of the solar generation, then solar will have this typical bell curve, which is shown on the right hand side bottom chart. You will either end up letting certain amount of solar energy go west, because in most of the regions, at especially at megawatt scale, for commercial industrial customers, very few utilities can support net metering. So beyond residential customers, I think we are seeing a trend around the world that net metering is not available. So in such case, either you end up putting much lower solar capacity so that you don't waste any solar energy, or you put higher solar capacity and waste that energy. Instead of that, if you can add storage, then it can help you in smooth out significant part of the demand fluctuations in the rest of the day, as well as help better utilization of solar energy. Now, one aspect which is very important, which a lot of time gets neglected, is that a lot of discussion gets focused just on the dollar per kilowatt hour price of storage technologies. Whereas we have been seeing for more than now 5 years that if you choose the right storage technology, which has a right cycle life, the right depth of discharge, the right C rate, that is how fast it can be charged and discharged, then there are economic cases existed for more than 5 years. And I'm really glad that some of our industry colleagues from AES and others will be speaking later on, because they can share some of the experiences where they have built now more than 500 megawatt of storage portfolios by capitalizing on these existing cases. But it is very important that you understand some of these key technical parameters, because choosing the right storage technology is very important. Otherwise, if you just go for tender for L1 type of technology, where you just end up choosing a cheapest battery available or cheapest storage technology available, you may actually end up suffering, because either in form of energy efficiency or in form of the expected life of the project, you can be in for a serious shock. So we have a number of different tools. So this is a tool which we ourselves as a customized energy solutions have developed called COMETS, comprehensive market evaluation tools for storage, where you can import various load profiles, you can import solar or wind generation data, and you can optimize the size of the storage project, as well as look at what different value propositions can be provided by storage for either behind the meter or in front of the meter customer. We have also worked with agencies where, like IRENA, where jointly we have developed a energy storage valuation framework, which is now available from IRENA, where you can look at it more at a systemic level assessment, starting from identification of energy storage services, what services can be provided for supporting variable renewable resources, map the storage technologies with identified services, then do the analysis at a system level to understand how much system level benefit is coming in. Does the existing regulatory framework allow you to capture all that value? Or if not, identify any specific incentive structures which are required for accelerating the or kickstarting the market. Here is just again an example where you may see that, okay, the system benefit of storage is significantly higher than the cost, But at the same time, because of the existing regulatory frameworks, if all those values are not being captured, then commercially you may not see a storage projects taking off. Now, this is a challenge which we are facing right now in India, where apart from the few projects so far, everyone is waiting for some of the regulatory changes. And this is a problem not unique for just India or for US. I think almost every country in the world is facing similar challenges. And that's a part where policymakers need to take little bit proactive steps and realize that if there are any inefficiencies because of existing rules and regulations, then you may need to create an economic viability gap funding for supporting it. But the way the price trend is going, we are seeing that within next 2 or 3 years, we don't need any more economic viability gap funding. It's just that for next 2 years, in some regions, this type of a support may be required. So we are seeing this is a map from US Department of Energy, which shows energy storage projects happening around the world. Again, they focus on US, so some of the other regions, all projects may not be captured, but just as an indicative, you can see that storage is no longer remaining just limited to US or Europe. You are seeing storage projects happening everywhere from Japan, Korea to Europe to Australia, India, China. So this is a global trend, and that's where there is a great opportunity for also building and supporting a robust manufacturing ecosystem. Now, China took a lead in setting up the advanced energy storage manufacturing capability. Europe has stepped up in last 2 years, and significant amount of new capacity is getting built in Europe. And now US and India is also expected to follow soon. Now, in terms of the global demand for stationary market, and this is only for stationary, I have not included numbers for e-mobility here, which are in fact, if you look at 10-year numbers, then e-mobility numbers are actually even bigger demand for than stationary energy storage. But just within the stationary storage, we are looking at somewhere around more than 300 gigawatt of demand of varying duration. So this could be anywhere from 2 hours to maybe 6 hour kind of a storage duration. And especially as we start getting closer to 2030 with higher renewable penetration, we may even have a need for long duration storage technologies which can provide 10-hour or longer duration. So the total in terms of the gigawatt hour scale, we are looking at terawatt hour demand for storage technologies in the coming decade. Now, looking at specific learnings from different areas. So if you look at market like US, which has been a leader in this area, the entire market got started when a company like AES did the first demonstration project with frequency regulation using battery energy storage back in 2008, 2010. And that ended up giving enough confidence to various state regulators to come up with policies for enabling such ancillary service procurement, and that kickstarted market. And once there was enough confidence in the industry, RE plus storage projects also started happening. And now there are almost around 8 states which have come up with specific storage mandates, where US is expecting almost close to 100 gigawatt of storage deployment by 2030. If you look at other parts, on the other side of the map, Australia, this is a classic project which has received a lot of publicity. But in 2017, after a sort of online debate, Tesla ended up proposing this 100 megawatt project as a solution for some of the transmission issues which Western Australia was facing. And they had already suffered one blackout because of certain outages at a wind farm. They looked at all the technologies and ended up choosing this project with a 100 megawatt storage, 129 megawatt hour of storage project. And this project was built in a record time of less than 6 months from the starting of the selection of the project. And there has been many studies which have been done by the Australian energy market operator in last 2 years, which suggests that the project has already paid off its cost. And even the owners of this project have been very happy with this. And already right now they are working on doubling the size of this project. And this project is leading to many more such investments. So there is a tendency amongst many policymakers that you like to get 100% guarantees, or you like to get more studies done. But this is a classic example how if you understand the problem and if you provide a level playing field for for storage technologies to compete with all other existing conventional solutions, including transmission upgrades, including thermal power deployment, then storage technologies are actually coming up as a winner. And in next 2 or 3 presentations, I hope you will see more examples of this. Now, last, coming to India. In India also, we started having small-scale demonstration projects in 2015-16. AES and Mitsubishi took a major step by deploying a 10 megawatt hour storage project in 2019. And now we are seeing that most of the regulators have visited this project. They have seen it operational. They have seen some of the studies from it. And as a result, there is a greater confidence. And earlier this year, we already had some of the large hybrid tenders which came out, where one of the largest tenders will have more than gigawatt hour of battery technical storage, as well as few gigawatt hour of pumped hydro project coming up. So these type of tenders are expected to become standard tenders in the years to come. And this is just a truly a start of a decade for energy storage technologies. Now, to end, just as it was mentioned in the introduction, I'm also founder and president of India Energy Storage Alliance. This has grown to a more than 100 company alliance. So if you are interested specifically on the India opportunities, then I would encourage you to become part of IESA and visit our website to access various resources available, including magazine, podcasts, knowledge papers, as well as other reports. To conclude, over last 5 years, the policy framework for energy storage have evolved around the world. Energy storage technologies have shown similar cost curve as what has been demonstrated by solar. There are many technology choices available. Certain technologies are at a higher level of commercialization. But apart from pumped hydro, there are other technologies which are being seen as a more distributed technology, which can enable much wider deployment of renewables. We need to understand the not just technologies, but also application requirement. And you cannot just keep sitting in isolation waiting for the battery prices to come down, because as it happens with laptops or as it happens with cell phones, there is always going to be a better phone, better laptop available next year. But if you can get more productivity from using that technology right now, it is worth investing into that right now. So same is happening with storage. And again, with next few presentations, you'll hear how other companies are actually drawing value from these technologies. So RE plus storage is clearly a winner, and we believe that it is not only going to be competing for peaker generation, but in the coming decade, it is going to become even a very cost-effective baseload solution. So with that, I would like to once again thank ISA for giving me the opportunity to share these insights. And if later on, if there are any questions, I'll be happy to stay back for the panel discussion and answer any questions. Thank you.
Thank you, Mr. Walwalkar. Thank you for this comprehensive presentation. As one of your slides summed it up already, energy storage technologies are in early stages of achieving economies of scale. And as the costs come down, markets will expand, thus providing more opportunities to scale up. And that is where the collective efforts at every point of the value chain become so important to utilize this technology and develop advocacy in favor of it. Thank you very much for joining us. Moving forward, transitioning to electric mobility will require a carefully planned strategy that is comprehensive and cognizant of the local context. Through the right policies and investments, local governments can encourage the consumers to make the right choices. Our next speaker for today, Mr. Amit Bhatt, Executive Director, World Resource Institute, will put a spotlight on electrification of transport with a special focus on opportunities in India. Mr. Bhatt, the floor is yours, please.
Thanks a lot, Mega. I hope you can hear me.
Yes, please, carry on.
Yeah. So basically, I think a lot of great suggestions have been made basically on why we have to look at electrification of transport. And I will not go into detail, but the point has been made very clearly that currently about more than a third of our energy is coming from non-coal sources. And this number will anyways go up. And what Rahul was showing in the earlier presentation, that even some of these technologies have been already cost competitive since 4 or 5 years back. So as we move forward, the share of renewable sources, clean energy will only increase. And we as a country have already made a big commitment to increase that share further. The question is therefore, why are we talking about this transition. I think from one side, yes, economically also it makes sense because a lot of fuel that we consume in transport sector otherwise is not being produced in the country. And therefore, it's also that if we shift to these cleaner sources, we are also looking at reducing our dependence on imported fuel. And that is another case on why we have to actively look at shifting this curve. The other side, which is also mentioned in the previous presentation, that why are the benefits that we get from renewables as well as from looking at power grids, and what does it mean for us? And that is also very well established in the previous couple of presentations which were made, and I will not go into detail. But if we have to summarize on why are we looking at, definitely air quality is one big area of concern. And that is why I think shifting to cleaner modes of transport is vital. We have to mitigate GHG emission. And we know that transport is one of the leading causes of GHG emission. And therefore, as we look at a cleaner and better India, we have to also look at cleaning our emission as well. Then, yes, we cannot rely endlessly on fossil fuels, so we have to promote renewable sources of energy. We also have to look at securing our energy sources. We have to increase plant load factor, and most importantly, that we also cannot let go the technological leadership which these opportunities are presenting to us. And if this is not the case, then this slide should actually talk about why we have to look at zero emission vehicle. Because 14 of the 20 most polluted cities which were recently surveyed were found to be in India. And in fact, some of the recent studies done in Delhi suggest that almost 40% of the local emissions that comes in terms of particulate matter, which are 2.5 micrograms and below, are coming from vehicle exhaust. And 80% of the NOx, SOx, and CO emissions are due to these vehicles. So if none of the above criteria warrant shifting to cleaner energy, I think this one slide definitely warrants that why we should look at zero emission vehicle. And the impact is not very minuscule. Please understand that the emission that comes has a massive impact on human health. So when you look at particulate matters, whether it is 2.5 or 10, they have a very strong linkage with heart diseases, with respiratory infections, even lung cancer. You look at ozone, which is a combination of NOx, VOC, and sunlight. We are looking at ailments like asthma, reduced lung function. NO2 emission have been found to have a direct impact on lung function, causing bronchitis and other diseases. And sulfur dioxide has been linked to right from irritation of eyes to asthma and bronchitis. And therefore, I think we are really talking about human health, which is at risk. And therefore, shifting to cleaner mode of transport is vital and important. Now, if that's the background, the question before us is, when we talk about electric mobility, is this the vehicle of electrification? Because there's a lot of buzz going around various forms of electric mobility, which have to do, whether it is the Nissan Leaf or Tesla or Toyota Primus and things like that. And I think this is where we have to start looking at slightly more detail, because electrification of transport does not mean electrification of passenger car in many geographies around the world. And therefore, as we look at a strategy for electrification, I think we have to look at some of the fundamental questions of how do our cities move, and then devise a strategy and roadmap accordingly. And I'll share some example which are slightly linked to it, which are from India. But I think some of these implications would be relevant to other countries as well, as we start looking at a long-term future of zero emission vehicles. I think first we have to actively look is what's the overall composition of our vehicle fleet. And then if you look at this chart from India, and this is some of the domestic sales that were done somewhere between 2012 and 2018, more than 70% vehicles that were sold were two-wheelers. And therefore, when we talk about electrification of transport, we cannot neglect two-wheelers. Then comes three-wheelers. And even in passenger vehicles, which are cars, smaller cars form a huge amount of vehicle sale. So we are really looking at 98% of our fleet, which is comprising of small and affordable vehicle. And it's only 2% which contributes to high-end car sales. Now, this is very important for us because this will have a very strong impact on our strategy for electrification of transport. So vehicle fleet is a very important criteria to be looked at. And we'll come to later on how we will use this as part of our electrification journey. Second is, let's look at how people travel in our cities. And this was the survey which was done by NTDPC in 2013. And if you look at cities which are more than 5 million plus in population, we are looking at almost 25-35% people walking. Then another 30 to 50% people using public transport. Motorized two-wheelers varies between 10 to 22%. Three-wheelers, which is an informal mode of transport, auto rickshaws as we call it, have a huge share between 5 to 15%. And car-based mode of transport in our cities, even in big cities, is almost less than 15%. And again, this drives the point that the bulk of our population in our cities, even with cities which are bigger in size, even with Indian standards, are not using private cars as a mode of transport. So how do we get the maximum benefit? That will be dependent on how can we clean our public transport, two-wheelers and three-wheelers as well. So that's point number 2. What's the catalytic vehicle that we should look at to drive the electrification story in India? Now, the third important point is what's the trip length? Now, trip length is typically an average distance that a person travels. And therefore, if you look at this trip length, and this came from the 2011 census, that a bulk of the population in the city in India, and this is excluding the agricultural workforce, does not travel to work because they live in very close proximity. But 71% of our all trips are less than 5 kilometers. And 16% of these trips, only 16% of these trips are greater than 10 kilometers. Now, this is again a very important aspect because as we look at sizing batteries, as we look at creating form factors of electric mobility, we have to understand that trip lengths in our cities predominantly is a very low distance trips. And therefore, I think, and that is also because of the fact that our Indian cities, like many other cities in Southeast Asia and other parts of the world, are dense. They have mixed use, and there is a very large proportion of people who are walking. Therefore, this is another important aspect that we have to keep in mind, as it will have a huge impact on battery sizing as well as range of vehicles that we are looking at. The fourth important aspect that we have to look at is what's the travel speed and what's the ambient temperature. And if you look at cities, the average vehicle speed in our cities is less than 25 kilometers per hour. But if you look at peak hour travel speed in the Indian cities, it is almost less than 15-16 kilometers per hour. Now, this is a very important aspect because we are looking at cities which are on an average moving less than 20 kilometers per hour during peak hour period. And therefore, what will this speed result in terms of the battery performance is something to be considered. Second, the ambient temperature in most of the cities exceeds 40-degree threshold. And sometimes in cities like Delhi, where I'm speaking to you, the summer temperature goes even high as 45 degrees centigrade. Therefore, the question then becomes, what will be this impact of low travel speed and high ambient temperature in terms of battery life? How are we going to cool our batteries? How frequently are we going to replace the battery? And all these will have a very strong impact on the total cost of ownership of electric vehicle. Now, therefore, the key question for us is, how will this impact our electrification approach? And I believe that that our approach has to be different from the way some of the Western countries are looking at electrification of transport. Now, we know that EV costs more than 1.5 to 2 times of internal combustion engine, and that is mostly the upfront cost. But we also know that the battery prices are falling, but it will still take some time for it to become considerably low and become at parity with internal combustion engine in vehicles. And this is mostly the upfront cost that we are looking at. So that's something that we have to look at, that how can we make sure that these price points are comparable. Second, we have seen in many geographies that there is a huge subsidy on procurement of electric vehicle. The subsidy may be going down, but these are the subsidies which some of countries like India cannot afford to start with. And therefore, I think our approach has to be slightly different. Now, the question really comes, should we wait for the battery prices to fall? No. Because if we wait for the battery prices to fall, we will end up importing a lot of vehicles and technology that will have a huge impact on our economic productivity as well as jobs. Because the current system, the incumbent automotive industry contributes almost 7% to the GDP and provides huge employment base. So the question is, how can we make sure that this transition also happens without hurting the GDP as well as the job security for the country? Now with that background, I think we have to really look at these 4 pillars of mobility ecosystem that we have to consider very kind of categorically in terms of transition. One, I think the vehicle side, both personal and shared. Second is the re-energizing system. And that's where we also have to look at charging infrastructure coupled with swapping infrastructure, battery swapping as one of the options for re-energizing the system. Third is the battery itself. This includes the lithium-ion batteries as well as the battery management system, and also other factors which includes manufacturing capacity, research and development, grid, so on and so forth. Now, if that's the entire mobility ecosystem we are looking at, the question then becomes, how should we go about transitioning to this mobility ecosystem? So, where do we stand? So right now, the current challenge that we are facing is quite a few. Limited driving range, long recharge time, high capital cost, resistance to change, availability of key battery material. Now, if that's the challenge, then our strategy should be that we have to recognize our uniqueness in terms of the mobility profile, the city profile, the geographic context, and then adopt this into our EV strategy. And that EV strategy should result mostly in a 3-pronged roadmap. And that is something that needs to be looked at very carefully. Now, when I say the three-pronged roadmap, the three-phase roadmap, what do I mean? I think first is the pilot phase, which is basically a proof of concept. Vehicles which have a very high demo value are to be deployed. And for transport scenario, we are looking at intracity buses because they do anywhere between 180 to 250 kilometers per day. And we know that the higher the usage, the lower is the cost of ownership of electric vehicle. So that is one. Fleet cars belonging to public agencies could be another. And some of this is already happening in the country. The other important thing is to also look at two-wheelers and three-wheelers, both three-wheelers from the shared vehicle perspective and two-wheelers from the personal vehicle perspective. Now, once the pilot phase, when that gets over and which is currently underway, we have to look at the scaling phase, which is where we have to create incentives and persuasion so that these pilots don't end up at pilots, but there is a scaling up which happens. And this may also involve some kind of financial incentive as well. Free parking is something that to be looked at. And many cities in India are actually gone ahead and limited the electricity tariff for electric vehicle, which again is a great facility. The other thing we have to look at, how can we also convert our parking into e-parking? Because that's where the parking can be developed as charging as well. And once that happens, the third phase is where things move on its own, which is we have established a technology used by people in normal course, and then it goes on its own. So pilot phase, scale-up phase, and a self-propelled phase can be the roadmap for electrification of transport as we look at our uniqueness in terms of the mobility profile. Now, policies and regulation, definitely, and these are the regulations which will drive this change forward. I think one, we have to start recognizing that electrification of transport is a public good, and therefore it has to be that this electrification is not cut out by price disadvantages. So we have to look at strong case of public policy which can absorb some of the risk which come with new technologies, and also to bring parity with traditional counterparts. So few examples that are happening in the country. Many states have come up with an EV policy. For example, Delhi EV policy of 2019 focuses a lot on demand side incentives, and they have actually gone ahead and made sure that the vehicle for electrification in Delhi will be two-wheelers, three-wheelers, as well as shared vehicles, because of the uniqueness that I had mentioned earlier in this. And there is an incentive for people to scrap their internal combustion engine and move to EV. So that's a great example of a demand side policy. And then we have states like Telangana, Karnataka, who have also incentivized the supply side intervention, which is creating a kind of enabling framework for industry to set up its manufacturing base, to create, make sure that robust electric vehicle models are available by providing land at a convergent concessionable rates, and faster clearance for setting up EV facilities as well as storage facilities is another example of what can the supply side intervention do to incentivize the production of vehicles. I think we have from WRIs done an extensive work around creating some kind of documents on how can one guide these states and cities to follow electric mobility. And this work was done by WRI in close collaboration with IIT Madras and was supported by Shakti Foundation, and has a link where you can kind of download this paper and read more about this. But I think going forward, to sum it up, we have to recognize the unique challenges our cities face and then plan electrification of transport. Yeah, with this, I will end my presentation. Happy to answer any questions that you may have later on. Thank you.
Thank you, Mr. Bhatt. Improved air quality, GHG mitigation, improved public health is something each one of us on this earth, irrespective of where we are, vouch for. We have to look at the composition of the vehicle fleet, modes of commute, trip length, travel speed, and ambient temperature to begin with. And perhaps this also gives us a good point to kickstart the electrification journey in our member countries. Thank you very much for joining us, sir. With this, we move on to our next speaker. India is pushing for greater use of electric vehicles to reduce vehicular pollution and cut dependence on oil imports. However, infrastructure for charging the batteries in such vehicles is critical for achieving that objective. Bharat Heavy Electricals Limited, BHEL, India's largest power equipment manufacturer, is setting up a network of solar-based electric vehicle chargers in the country. We have with us today Mr. Rajneesh Goyal, General Manager BHEL. I would now request Mr. Goyal to share BHEL's experience in storage and setting up charging stations in India. Over to Mr. Goyal, please.
Thank you, Ms. Megha, and thank you, ISI, for giving BHEL this opportunity to share our experience. Is my presentation visible now?
Sir, your screen is visible. The presentation is yet to come up.
Only showing your directory now. Yeah.
No, it's stuck, sir. Bimalji, can you please help?
So should we put it from the ISA side now?
Maybe right showing resume share when I'm clicking.
Okay.
So if there is a difficulty, Bimal, you can load it from the ISS side, same presentation over the copy.
Please go ahead.
Sure, sir.
Okay, thank you. So I will be sharing BHEL experience in this new area, which is a sunrise area for the country itself. And before that, I just like to give you an overview of BHEL. Can we move to the next slide, please? So basically, BHEL is a major engineering enterprise, majorly in public sector, this power sector region. And in the last 2 years, we have forayed into this new area, and we have taken some new initiatives to establish our offerings in this area. And our major offerings are e-bus, chargers, lithium-ion battery packs, and motors and controllers. Please move on to the next slide, please. Hello. So that's what I was sharing. The BHEL in the 1980s also developed this e-van on their own initiative, and some of these buses ran in the city of Delhi, and you can find still running in Taj complex in Agra. So of course, those at that point of time, the technology was lead acid battery, but it just establishes the basic engineering and manufacturing expertise the BHEL had at that point of time also. But these buses are still running in Taj complex, and we have successfully giving for in Indian Railways the traction motor converters as our offerings to this industry. And we have a state-of-art facility for space-grade lithium-ion batteries at our EAD in Bangalore plant for ISRO applications. And for our in-house development, these motors, which we have specially developed for EV applications, were successfully tested at ARI, and they are liquid-cooled motors, compact design, very rugged, and high-efficiency motors. And we have got our 12-meter bus homologated, and 9-meter bus variant is also under development. Next, please. Can we move on to next slide, please? For the EV chargers, we have developed the 120 kilowatt charger and with CCS and different protocols, and we are executing some commercial projects. Now, specifically for this Delhi Chandigarh project, I will share my experience. What BHEL did this Delhi Chandigarh in the FAME1 scheme, we got a project approved for Delhi Chandigarh highway solar-based EV chargers, and we conceptualized this project, and we have commissioned this project. And can we move to the next slide? We have also developed a fuel cell for EV applications, which we have as a proof of concept. We have incorporated in fuel cell card, and now we have tested the 2.5 kilowatt and 5 kilowatt fuel cell also is under testing. Now coming specifically to this solar-based EV charging stations, you can see this from this photograph. These solar panels here in this photograph we have used as a canopy for the charger itself, and sometime in some other areas we have installed at rooftop. So what were the key objectives of this project? Were allaying the range anxiety, improving air quality, and basically giving a concept of charging stations backed with total green energy. And this was the first highway which was declared e-mobility friendly by DHI, and this was one of the first major projects in the 100 days agenda program of the Government of India. So these locations of these charging stations were strategically chosen so as to have equidistance charging opportunities for the EV vehicle commuters, and 20 number solar chargers, solar-based EV charging stations were planned, and 11 numbers are already commissioned, and we are going to complete the project by January. And by this installation, this complete Delhi Chandigarh highway has been covered, and presently, if you see both the sides of the highways have been covered in these projects. If you see the project, what is the basic total scope? It is based on net metering concept, and the charging stations AC charger, 2 AC number charger, 2 DC001 chargers, along with isolation transformers, complete block diagram you are seeing here, along with rooftop solar were conceptualized and commissioned. Next, please. This is a SLD of the project, solar project, and you can see the string of converters and the detailed studies how the configuration was done so as to match the specific layout of the resorts, because these were located at Haryana Tourism Resorts. And if you see in the next slide, please go to the next slide. See, these rooftops which were available, they were at different places. So the accordingly the configuration of the solar plant also has to be decided, and the complete layout has to be done in a way so that it doesn't affect the aesthetics of such a plant. So this is how the concept was done. So what were the basic things which we faced and planned? That okay, one is the strategic locations and site surveys along with the landowners, the property owners, how the system, what is the loads available, enhancement of load is a major consideration, because all these facilities are quite old, and so what is the load enhancement available, how much solar plant can be installed at various rooftops, what is the structure available there, what is the space available. All these considerations have to be overcome and discussed with the stakeholders before you conceptualize and actually put these things in place. And apart from this, next please. Getting clearances from various organizations like PESO in case of petrol outlets is a major hurdle, and coordination with DISCOMs, land authorities, various agencies takes a lot of time, and smooth execution otherwise which will take 2 3 months, sometimes take 6 to 9 months. So this is a major consideration and constraint in implementing such projects. What we find that okay, that with the solar-based EV chargers, the recovery period is 4 years. If the utilization is also quite low presently. Even with 33% utilization, the backup, the break-even time is 4 years, and it will be even more, and even not reachable with lower utilization. So that is how do we scale up these projects is a major consideration, because solar plants are not being covered under FAME scheme of the Government of India. For battery energy storage systems is a typical block diagram of a energy storage system. You can see, and this we are all aware. You can go to the next slide. Already covered by the other, but we conceptualized a 1 megawatt hour plant at our corporate R&D with 3 chemistries: lead acid, lithium-ion battery, and flow batteries, and to study the various chemistries and how they perform for the grid application. If you see the next slide, is a comparison of the 3 chemistries for this plant. This is just a view of the various chemistries and the containerized battery packs what we have installed there. We have a in-house developed PCS, 630 kilowatt PCS, and EMS also we have developed in-house. Complete turnkey solutions are given by BHEL for energy storage solutions. And these are the major components. Then we have also got one maiden entry into this energy storage market with a 410 kilowatt hour energy from Terry. And these 410 kilowatt battery energy storage will be installed at 3 different locations for different objectives. One is the managing the distribution transformer overload, backup power, and optimizing the tariff time of day tariff. And complete EPC solutions are being implemented by BHEL. So any queries are there, I will be very much keen to answer, and any requirements are there, you can contact me on these contact details. Thank you.
Thank you, Mr. Goyal. Thank you for giving us the 360-degree view of the project on Delhi-Chandigarh Highway, and also telling us about the turnkey solutions BHEL is providing. With this, we move on to our next guest. Our next guest is Mr. Rajendra Srivastav, President and Market Business Leader, AES India, and MD and Chairman for a JV between AES and Mitsubishi. AES, ladies and gentlemen, is the world leader in lithium-ion-based energy storage and believes that energy storage is a force multiplier for carbon-free energy. AES's contributions in energy storage have enabled hundreds of utilities worldwide to reduce their reliance on thermal generation. I invite Mr. Srivastav to share AES's implementation experience of energy storage projects with our guests. Over to Mr. Srivastav, please.
Thank you very much, and I am privileged to speak in this August gathering where I have seen some of the presentations with a huge depth and knowledge. I'm going to restrict myself to what we do and how we do and what is our takeaway. But just to give a context, AES is a global company present in 15 countries, and we have a huge ecosystem of renewable. We build almost a couple of gigawatt each year on the ground ourselves. We have a huge ecosystem and the ability to build energy storage. We are doing it for a long time. I'll explain later on. And we are present in India for a very substantial number of years. And that shows our commitment to the India's commitment to this country. At the same time, we are also doing renewable worldwide, and we have done something very unique in India. So we can go to next slide. This is to say, I've heard a lot of people that things will move and things will become less complicated, less expensive. Please remember, we got into energy storage. Okay. There's a lot of background noise, so if people can switch off there.
You to kindly mute your mic.
So we started energy storage as far back as 2007. Can you imagine that some of these installations we moved to Hawaii Island after a hurricane as it is lock, stock, barrel and reconnected to the grid? That shows the durability of the energy system and the robustness that we have proved. So IPL is Indianapolis, we own that. DPL also, IDPL we also own. PGM is the like a POSOCO who owns these assets built by us. So you see all along, and somewhere as we go to Edison, where we are building one of the big monster size energy storage at our own cost, and I'll talk about it later. And then we also built in the year 19 commissioned a 10 megawatt storage connected to the grid in Delhi, and it's operating very well. Next, Adi. I want to only talk about what we have done and how it can benefit the ecosystem of energy storage within India and worldwide. Look at this Alamitos project. This is right in the middle of the town. and it's going to be commissioned soon. Actually, it's more than constructed and near commissioning. It's a 100 megawatt battery, 400 megawatt hour energy capacity. Imagine it was a global tender where everyone could have bid, whether gas, coal, and we won against the global competition on a gas-based plant because we didn't consume water, we didn't pollute, and we got the minimum land area in the middle of the town, running into less than a couple of acres. Compare this with the water supply required for gas turbines and so on and so forth. And at the same time, the energy storage gave both sides absorption as well as dispatch of energy. Whereas in case of gas, actually you can only supply energy, you cannot absorb. So these are some of the distinguishing features. And please keep in mind that more and more such competition will happen. And I'm sure that energy storage will be preferred over others because we are zero emission and zero water consumption solution. And it can be set up in the middle of the town where the load is. Next. I heard a little bit about the solar integrated with energy storage. We have already done there. We are already operating it. Imagine it's more than a year. Hawaii Island actually floated a tender and we bid and won this 28 megawatt solar AC capacity and 20 megawatt, 100 megawatt hours to displace energy supply in the later part of the evening, right up to 7, 8 p.m. every day. This price at which we won was, I think, 8 or 9 US cent. Remember, this island has no manufacturing, no supply chain, nothing. So we lifted everything, brought it on shore and assembled at less than 10 cents. The success of this project now enthused the Hawaii Island authorities, and we have got 2 more orders. And we were going to build much more of renewable integrated with the energy storage and with the prices going down. This is, can we have a silence, please? I'm distracted. Thank you. So what I wanted to mention is that this is a reality. Solar integrated to energy storage is a reality. In fact, I'm going to talk about another solution which we have patented. It's called virtual zone later on. But this shows that how we are displacing the energy. If you see the graph, the battery is charged by energy storage, and then that energy is discharged in the right side under the blue shaded area. So you have a seamless supply of energy for almost nearly 18 to 20 hours. And remember, the cost of energy is competitive. We can go to next. This is Delhi. I want you people to please find time to visit this. I have heard so much about people talking about energy storage, but this is the only one which is built at a grid scale, 10 megawatt, 1 hour, operating for more than a year. And it can do DSM management. Tata TPDDL is saving money by reducing the deviation settlement penalties. They can do peak and off-peak management. We can do frequency regulation. Unfortunately, there is no payment for frequency regulation in India. And we are trying to educate the regulators that we should be paid for fast response. I'll share with you a graph which shows how brilliantly this works when the frequency of the grid goes down. And also, I want you to visit this and understand that how this can be as a market opener for all the industry in India. The next. I think this is not the one. Yeah. Just spend a minute here. See the response. The dark blue is the response of energy storage. As the frequency is going down to 50 or below, as soon as it goes back to 50, energy stops discharging from the asset. As soon as frequency goes down, it starts pumping up. Remember, 10 megawatt is not a huge thing, but it proves that within less than 100 milliseconds, we supply full capacity of energy storage to the grid. This is to prove that frequency response is real We shared this with the regulators. They were very surprised because they don't have this curve. Anywhere in India, I have not seen any curve where where the energy storage asset has responded to the grid frequency. But here we have many such examples. We record 30,000 data every 2 seconds. So we are huge with data information that we are collecting through this 10 megawatt energy storage, which is running for more than a year. Next. This is the invention and patent that we have done, AES. This is called virtual dam. And the brilliance of this solution is, and I am telling you, all of you audience, what we have done. We have designed, built, integrated, done, and operating. So we have a Alfa Laval, we have a hydro plant, which is at 1300 meter and a deep tunnel. And what we have done is we have initially installed a 10 megawatt 5-hour battery storage, and it's already commissioned and commercial operation begins this month. What it does is that during the day, and remember in Chile, it is the market price, there is no PPA. So in Chile, we get, since the hydro plant is old, we get a small capacity charge, but we supply power to the grid. And during the day, when there is an off-peak hour, we store the energy in the battery storage and then supply in the peak hour and use the energy arbitrage. That means the energy used to charge these batteries from the hydro versus the energy we sell in the grid during peak hour gives us a payback of less than 4 years. We are going to scale this up to 60 megawatt and maybe another 5. Adi, you can correct me. I think it's about 200 megawatt hours.
200 megawatt, 5 hours, 1000
hours.
megawatt hour.
That's the level we are going. This is called virtual dam. Imagine we can build this in every hydro plant in India, and we can give the grid a spinning reserve without any hydro plant curtailing their dispatch and then preserving that as a spinning reserve. We can even do it for the thermal plant, and all the generation station can be freed from spinning reserve obligation because we can supply for 4 to 5 hours 100, 200, 300 megawatt to the grid at a fraction of a second demand. This is a brilliant solution. We have proven it, and this is available. And by the way, the battery prices are going down. I'll talk about it a little later. We go to next. I've heard a lot of conversation about battery prices going down. I have a theory that even if battery prices become zero, look at the blue line below. And as we go down, the blue line goes down to 69 dollar per kilowatt hour. Even if it becomes zero, please remember that the batteries have to be housed in a system, communication system, package, the cages, the hardware, the firefighting, the AC and everything. There is an infrastructure cost of maintaining it. So please stop using the jargon of battery prices going down. Battery prices have become, by the year 2030, 1/4 of the energy storage cost. So start thinking battery price like a solar panels, they will continue to go down, and eventually it is the financing and mounting structures and DC cable and AC cable, they will start dominating the cost and not the battery price. So I want you people to please recognize this point, that wherever I go for a discussion, everybody wants to know what is the battery price. My answer is, what is the system price? And what do you want to do with this? For example, in Alfa Laval, it didn't matter what the battery price is. And I also want to tell you that we are building a 180 DC, 180 AC plant in Los Andes in Chile, and 115 megawatt 5-hour energy storage in Los Andes. It's under construction. And that is competing in, again, the market, the grid, at a market price. Again, I'm telling you, there is no PPA in Chile. It's all market driven. So these are the real things we are doing in real life. Can we go to next? So I would like to then practically sum up my saying to all of you that please remember the world is moving very fast on energy storage. We are building a huge asset in US, which is Adi, I think the latest is 400 megawatt and 1 hour, something like that.
Yeah,
And
100 megawatt 4 hour.
4 hours.
Sure.
And this is connected to the grid. And I would urge to all of you that please see beyond the immediate discussion that we have as to how the battery prices are going down, etc., to something which is an absolutely innovative and path-breaking application. One, renewable energy integrated to energy stores. Second, look at virtual dams, which will release the spinning reserve. Let regulator come forward and encourage this installation in discoms and also in the POSOCO. Allow them to build 100, 200, 500 megawatt hour systems. And lastly, these systems can give you a black start like Bombay, and we can really save the cities from drowning. If there any question, please, Adi is there. I have to hop on another call. Thanks for your attention and wish you all the best.
Thank you, Mr. Srivastav. Thank you for this insightful presentation and for showcasing so many case studies. You have designed, built, integrated, and operationalized the projects. And I'm sure the attendees would like to understand the modalities of these projects in detail during the interventions. With this, we move on to our next and the last speaker. The last presentation for today is on e-mobility and charging infrastructure by Mr. N. Mohan, Deputy General Manager, EESL India. EESL, ladies and gentlemen, is developing electric vehicle charging infrastructure and has signed MOUs with multiple stakeholders across municipalities, DISCOMs for locational assessment study and setting up of charging infrastructures in their respective jurisdictional locations. Over to Mr. N. Mohan from EESL, please.
Yeah, thank you, Mega. Hope my screen is visible now.
Yes, please. Go on.
Thanks, Mega. So thank you, ISA, for having us here and giving us an opportunity to speak on electric mobility and charging infrastructure. So basically, I'll try to cover like what ESL has done and what's our experience in electric mobility and how we are trying to scale up this charging infrastructure across India. Just to give a just to give a background about our national e-mobility program. So we commenced this national e-mobility program in March 2018, and the major goal was to like achieve an economies of scale and probably at least like we can help the EV charging industries, the manufacturers and the fleet operators. So probably they can switch over to the electric vehicle as compared to the non-electric vehicles. We work on a concept called demand aggregations, where we try to aggregate the requirement across cities, so we can bring out that the large procurement for electric vehicles and chargers. So here also we follow the same principle of demand aggregation, and we come out with a large procurement of electric vehicles, which could be deployed across the major institutions. So in this process, we are able to deploy close to 1,500 electric vehicles. And also we have deployed close to 1,200 charging points, which are captive charging points. Normally, like whenever we are leasing out these electric cars to the institutions, we also build up the captive charging stations for the leased electric vehicles. The image below is one of the largest deployed electric vehicles by ESL. We have deployed close to 70 cars in the state of Kerala. So where we replace the entire fleet of non-electric vehicles used by the Kerala Motor Department with electric vehicles, and you can imagine the 70 e-cars have been run from last few months' time. So where they shown like a lot of the savings have been achieved because of reduction in the fuel consumption which were incurring earlier. And these electric cars are being leased to the institutions on a lease model. And typically, we try to keep the lease amount in such a way so there is no extra financial implication to the clients. So far, around 1,500 cars have been deployed, and we are trying to deploy scale up this initiative in across India now. This is about the national electric mobility dashboard. This would just to show like how this the benefit could be accrued by having the electric vehicle. If you can see here in the dashboard, we're showing like how many numbers of electric vehicles have been deployed here, and it shows like on real time like what is the reduction in the carbon dioxide emissions, how much like the monetary savings have been achieved by switching over to the electric vehicle, how many kilometers these electric vehicles have been achieved. So basically, like this shows like the cumulative kilometers achieved by 1,514 electric vehicles so far. It also shows information about like reduction in the particulate matter in terms of savings in fuel consumption. And also we try to capture some of the deployment state specific also. So by this dashboard, I think one could see like which are the locations or cities where the electric cars have been deployed, and what is in terms of the benefit these electric cars has brought to the stakeholders. So if you look at the EV ecosystem challenges, I think the previous speaker has touched upon like some of the existing challenges in the electric mobility. Initially, like when ESL commences operation the electric mobility, we are focused more towards like enabling some of the existing IC cars using the government institutions, so that they can switch to the electric vehicles. But soon we realize there's a larger opportunity which exists in the private and the fleet operator segment. So we realize like there is an infrastructure which has to be built up. So at least the private and the fleet operators so probably can look at electric vehicle as one of the mainstream for their business segment. Broadly, I try to put up some of the ecosystem challenges. One is, of course, the high upfront cost. The second is the limited electric vehicle models which is available in India, and third being the lack of charging infrastructure. If you compare the existing electric vehicles and the IC vehicle, already like this in the premium one has to pay for acquiring the electric vehicle. To some extent, I think the FAME 2 policy has able to at least bring down this acquisition price to an extent. And the another concern remains the limited electric vehicle model. If you look at the existing automobile market, at least consumer has a choice where consumer can go for a different kind of IC vehicles and with different price range. But if you look at the electric vehicle model presently, like we have hardly like 3 or 4 electric vehicle model which is available. So consumer has a limited choice. And there is a need where the electric vehicle OEMs probably they can bring out a lot of new electric model which are more efficient and probably I think which they can meet the within the range and expectation by the consumers. And third and foremost being the lack of charging infrastructure. So here presently because of low density of electric vehicles on road, there is a viability issue with respect to building up the public charging infrastructure. Second, the existing the infra cost for this charging infrastructure are pretty high, and considering the low utilization, these will have a longer payback. And in cities, building up the stations within the city and within the city limits would increase the operational cost, and also like getting the land parcel for building up these stations is quite a challenging situation. So how these issues are being addressed under the policy and the regulatory framework, so which I will just brief in the coming slide. This is about the FAME scheme, so which is built on the initial traction by the FAME 1. The FAME is first adoption for manufacturing electric and hybrid vehicle. So here the FAME try to incentivize the consumers by allowing a demand incentive. So at least the cost of the electric vehicles could be reduced. So these cost becomes comparable with the IC cars. So broadly, 10,000 crores have been earmarked into the FAME2 scheme, which commenced from April 2019, which for next 3 years till 2022. They try to incentivize the two-wheelers, three-wheelers, four-wheelers, and electric buses. And prominently, they are also earmarked 1,000 crores for the charging infrastructure. So based on the battery capacity, they try to define the demand incentive. For example, for electric buses, they're providing incentives at the rate of rupees 20,000 rupees per kilowatt hour. Likewise, for other segment of vehicle, they're providing incentive at the rate of 10,000 rupees per kilowatt hour. This demand incentive is being given to the OEMs directly, so the net benefit is passed on to the end purchaser. Also, they're presently looking at the initial adoption, which primarily would happen in the commercial, in the public vehicle segment. The demand incentive for electric three-wheelers, four-wheelers, and buses are being specific for the commercial segment, and is only allowed for to qualify for such incentive. Largely, I think the charging infrastructure has been given a major impetus, where they have kept the flexibility of funding to extent of 100% based on the category of the charging stations one would build up under the FAME2 scheme. I'll just touch upon the charging guidelines which were issued by Ministry of Power. So initial guidelines were issued in December 2018, and subsequently the amendment happened in 2019. The broadly, I think the guidelines states that like the charging station has to be built in a radius of 3 km by 3 km, and a fast charging station has to be built in every 100 km on both sides of the highways. The basic idea behind having the grid of 3 kilometers by 3 kilometers and the charging infrastructure is to enable that at least any electric vehicle user can access these charging stations with much ease. And also the public charging station has been made a deregulated activity. In a way, any organization or any entity planning to build up a charging stations can do so without requiring any special approval or permission for building these charging stations. In the recent guidelines which issued in June 2020, even the battery charging station, the battery swapping station have been included in the guidelines. So this has multiple benefit with respect to getting the service connection from the utility, and also the EV tariff which was applicable for the public charging stations will also be applicable for the battery charging station, the battery swapping station. In India, broadly, we have different charging protocols. The Ministry of Power guidelines also recognize multiple charger type here. So India, broadly, we have slow or moderate chargers which are basically like sub 100 volt charger connectors. And typically we call it as Bharat DC and Bharat AC connectors. In the fast, like we have gone and adopted the international protocols like CCS and CHAdeMO and Type 2 standards. So in India, like the charging stations could be built with specified charging connectors as per the MOP guidelines. So our experience, like we are trying to enable this ecosystem for the charging infrastructure. So we also realized, like once we start looking at some of the public-private partnership where we start like rolling out of electric vehicle segment to the fleet operators, we realize unless there is a strong ecosystem for charging infrastructure, it might be difficult for anyone to at least offer electric vehicles. With this intention and in mind, we start putting up the public charging stations in the public parking locations. And while doing so, we realize that there has to be a scientific approach which has to be followed. So at least the charging stations could be monetized, and probably we can achieve a better utilization from these charging stations. So broadly, we try to have a scientific approach where we realize that if the proper planning is not done with respect to setting up this public charging station, the city may end up having more number of charging stations completely unstructured, and perhaps it may lead to a lot of charging stations become obsolete in near future. So with this in mind, we developed an approach for putting the public charging stations where we followed the guidelines of MOP and where we try to characterize the city in a grid of 3 kilometers by 3 kilometers. We took a secondary assessment research where we tried to map some of the points of public interest. We also did a lot of consultation with the fleet operators, mobility partners, electric vehicle OEMs to understand the need for charging. We also realized like once we can map the charging locations as per their requirement, so probably I think this asset could be monetized and perhaps we can achieve a better utilization as expected. So we did this location assessment and subsequently we formed in survey teams involving multiple stakeholders. Then subsequently the implementation, operation, and also we focused more towards like ensuring like there is a sustainability of business operation where partnership and tie-ups with OEMs and the fleet operators is very much essential in the electric mobility and public charging stations domain. I will touch upon some of the like the basic scientific survey parameters which were captured. Although like this is not exhaustive one, just to give an indication like how the study was conducted. Broadly, we try to capture like what kind of the parking space we are focusing, which electric vehicle segment we are trying to target for building up this charging station. Is it 2-wheelers, 3-wheelers, 4-wheelers, or electric buses? We try to look some of the like infrastructure requirement there. What load would be adequate for building up these charging stations? What capacity could be built up? How these stations could be built up? What civil works are required for building up these charging stations? About the visibility also, we try to keep a separate tracking about the movement of the traffic, the density on those locations. And also we try to capture some of the points of public interest with respect to preferred points, especially with respect to the bus stations, the metro station, airports, restaurants, the tourist attractions. We try to capture all these checklists in our survey and we start deploying these charging stations. So at least we realize that once we have a proper stations in place at the right location, this would help electric mobility partners to use our public charging stations. Just an example like how this city grid mapping is done. This is a representation diagram just to show you like how the 3 kilometers by 3 kilometer grid mapping is done for a city and how we are trying to at least like do the physical survey at these locations. And the green markers indicates that these are the locations which could be taken up in the phase 1 of the implementation. And subsequently, we could focus on the priority 2 and the priority 3 locations. This would help at least in doing the urban mobility planning also. So where at least city can locate like how the city infra could be built up, how this mobility could be promoted. So in a way, we try to have this comprehensive approach for a city while deploying our public charging station. We ensure that we build the adequate number of charging stations for all segment of electric vehicle. So a sufficient charging opportunities are created for the EV users. This is basically to emphasize like how the location assessment could impact the end user tariff. If you look at the graph here, we're trying to plot the utilization percentage and how probably it can influence the service fee. Service fee basically like the end user tariff, which will be charged by the EV owners. If you look at the 20% utilization, we can reduce the service fee by 29%. And likewise, if you look at the 30%, 40%, perhaps I think we can reduce the end user service by 44%. This gives a real example that once you have a clear locations identified with right combination, perhaps it not only reduces the investment involved in building the charging infrastructure, and also it helps in keeping an affordable tariff for the end customer. Eventually, in the initial days of electric mobility, we feel the end user tariff would play a major role. If we can keep it affordable, probably I think the adoption will be much faster. That is what our experience also like shows. So we try to follow this philosophy of having a proper study done while putting up this charging station. And we realize that once we have a clear parameters assessed and checked, the utilization definitely could be achieved. and perhaps the benefit could be passed to the end customer. So also it also helps us in giving a proper assessment with respect to the grid infrastructure, which perhaps forms a major cost of the capex also. Once we look at these broad parameters, I think we should be able to build those the charging station in the most economical and efficient manner. Just touch upon the business model of what we follow. We realize like now bringing the investment in the charging infrastructure could be a challenge. So we try to work on a partnership model with many of the land partners, where we try to bring in the investment in the charging infrastructure, where ESL will have a service agreement with the land partners, and typically the responsibility of building up the stations which lies with ESL. And typically we work on a revenue sharing, where we part some of the revenue from the charging station to the land partners, so they also get benefited from the association. ESL as an unique value proposition which we brings for the EV users. Since we work on demand aggregations, since we consulted the requirement for electric vehicles and chargers at scale, we get the benefit of economies of scale, and also we have an access to low cost financing. Also, we are thankful to our partners like Asian Development Bank, World Bank, KfW, who are financing for the e-mobility energy efficiency program. So this way we are able to at least like build the stations, and we're also trying to keep that affordable service fee for the end customers. This is a portfolio of ESL for next 1 year. We plan to build up close to 1,100 EV charging stations across 10 major cities, and these being deployed under the FAME India Phase 2 scheme. We are trying to focus on some of the urban cities to begin with. We feel like the most of the commercial fleet will be transition would happen in the major cities, especially by the fleet operators. So the major emphasis is to begin implementation in these 10 cities, and subsequently it shall be expanded to other cities and the expressways and the highways. I'll touch upon this interesting slide on our charging business. So far, we have built up close to 1,200 charging points in the captive charging purpose across India. In the public charging stations, we have built up close to 200 EV chargers, which has close to 375 charging points. Means 375 electric vehicles will be charged simultaneously. So major of these public charging stations are in Delhi, NCR as of now. But we are planning to expand to other 10 cities as I briefed in the previous slide. If you look at our consumption, we have touched close to around 26600 consumption have been achieved. And we are happy that at least we have supported close to 1.5 million clean kilometers traveled by the electric vehicles. If you look at the graph on the below, so we try to put an analysis on the charging utilization. When we commenced our operation in May 2019, it's almost a year plus of operation for ESL. So initial utilization was below 4%, around 4 to 5%. But gradually we could able to expand and increase our utilization trend. And the major contribution comes from the fleet operators. Here, the reason being we're able to at least match their requirement by putting up the charging station at the required locations. Once we start expanding our charging network, we realized that the EV users are more comfortable and convenient in accessing our public charging station. And gradually, I think we are touching close to 15% utilization from our public charging station. If you look at the lockdown impact in April and May 2020, so most of the fleet operation was completely stopped, and you can see the real impact in the charging sessions there. So hardly there was any charging sessions which happened for 2 months. So the main reasons behind this utilization is we need to at least have a partnership with the e-mobility partners. That is the success where we feel could be achieved by having a proper partnership and a kind of engagement where we can build up the stations at required destinations. And just broadly to connect how probably there is a potential business case for the RE integration. If you look at our utilization trend in over a weekdays, it almost like remains stagnant. But the interesting part here, if you look at the day-wise utilization, so most of the utilization is coming in the afternoon here. So even we see like there is a large scope one could look at for doing the RE integration plus the battery storage. So we're exploring that option, and we're also planning to build some of the carbon neutral public charging stations. We will plan to like at least put up this decentralized solar generation with integrated battery storage at the potential location. So probably we can show that complete carbon neutral stations could be established. So we're in process of deploying it. But I think by having such analytics around the public charging stations, at least one could look at some of the like opportunities around the electric mobility and the charging infrastructure. So we are also happy that in July 2020, we inaugurated our first public charging plaza in India, in Delhi. So where we built up around charging stations which can charge 14 electric vehicles simultaneously. We try to build up the Bharat DC chargers of 15 kilowatt capacity. And also we built up 4 number of high capacity combo chargers, which has CCS2 ChargeMon Type 2 AC protocol, where 3 vehicles could be charged simultaneously. So these are some of the informations about like which vehicle segment it is compatible with. If you look at Bharat DC, these vehicles are compatible with the Tata and Mahindra variant. And the CCS, we have few electric vehicles which are compatible like Hyundai Kona, Tata Nexon, MG Motors. So we try to see like at least any electric vehicle approaching our charging plaza could use our facility and recharge their electric vehicles. Some of the photos of the installation in the public charging station in Delhi. The left side is the combo chargers where we try to build up the high fast charging stations with CCS ChargeMon Type 2. And the right side, these are the like slow Bharat DC charger of 15 kilowatt capacity. And these are some of the installations which are prominently been installed in the public parking areas. And this plaza we try to build up where only exclusive electric vehicles are allowed for accessing the facility. We realize that once we make more number of such charging plaza, possibly the EV users would be more comfortable accessing our charging stations. So we realize, I think the electric mobility and the charging infrastructure needs a lot of partnership. So ESL also working with several stakeholders. We work with the distribution utilities, we work with metro operators, we work with cab aggregators, land partners, EV OEMs, municipalities. So I think success in forging partnership, that is what we believe in. So we are trying to at least see we can create synergies among different stakeholders, which could help in creating awareness in electric vehicles, and also it helps in enhancing the operation of the charging stations. So thereby the business model becomes more sustainable. So in a way, like we're trying to have a synergies across different stakeholders. This is what we try to at least like bring into this forum. Lastly, I think we are trying to have the convergence of energy, technology, and mobility. That is what we feel is the way forward. We're trying to at least like bring in renewable energy, bring in storage, electric mobility. So I think there has to be convergence, which would happen. I think which is the way forward for all of us to push for decarbonizing the transportation. So with this, let me with this I thank ISA. So any question probably I would be happy to answer.
Thank you, Mr. Mohan. Thank you for sharing how you are enabling the ecosystem for charging infrastructure in India and for highlighting the key variables EESL has identified to assess the viability of charging infrastructure in India. I'm sure your learnings in India will be useful in identifying the variables in ISA member countries as well, as that is going to be the first step before we start integrating solar PV and storage. Thank you very much for joining us. With that, we move to the country intervention segment of today's webinar. We are very honored to have with us the national focal points and alternative national focal points of ISA member countries. We have the national focal points joining us from Comoros, Fiji, Guyana, Guinea, Liberia, Niger, Mali, Myanmar, Yemen. and the local contact points from Australia, Jamaica, Togo, and Tonga. With this, I would invite interventions. First, we will take up the national focal points, please. I would invite Mr. Omar from Comoros to please have an intervention. Mr. Omar, would you like to join us? Mr. Umar, you can unmute.
Mega, he has left.
Okay, sir. Okay, sir. The next speaker, the next national focal point I would like to invite is Mr. Mikel from Fiji. Mr. Mikel? I would...
Excellency Micah, if you can unmute and make country intervention if you wish to.
Sorry for the disturbance. Please, can I invite Mr. Mahendra from Guyana?
Mega, good morning all. Thank you very much. A pleasure to see you all again. First, let me extend gratitude to the International Solar Alliance, its members and the Secretariat for putting together these very useful webinars. Today's session was extremely informative. Guyana too is looking aggressively at e-mobility and how we can leverage this opportunity. To assist this, we've actually procured the Nissan Leaf, the Accenta, and I have been driving that car since February, and it's an extremely beautiful machine. It's a 40 kilowatt hour battery. We're getting about 215 kilometers on a single charge because I'm using the AC. Beautiful thing is that I'm able to charge it on my grid connected solar at the office, and I charge it on weekends. So the excess energy is used to charge the vehicle. So except when there's rainfall, majority of the energy from that car comes from solar energy. And what I intend to do is to encourage government agencies and ministries to have at least one electric vehicle procured, along with electric scooters, to help them with their transportation needs. Now, Georgetown is fairly small and a lot can be done with 215 kilometers. The only thing I'd like to see more of is discussions on electric car experiences. There's so many models out there, so many opportunities. It would be useful to understand what has been the experiences of various countries and various users of electric cars, and what worked, what didn't work, what concerns they have, because we can't possibly try them all. And we want to be able to find a way to assess what is useful in Guyana. So like India, you have a huge demand, and so you need to focus in on what kind of technologies would best suit you. So all in all, I think it was an excellent session. Thank you very much, and all the best. Take care.
Thank you, Your Excellency. I would like to now invite His Excellency Mr. Karim from Guinea. Mr. Karim from Guinea.
Oui.
No.
Hello.
We can hear you, Your Excellency.
Hello.
We can hear you. Please speak loudly.
Oui, oui, bonjour.
Mr. Karim, you can speak in French also because there is interpreter.
Je parle le français, vous savez. Bonjour. Allô, vous me suivez?
Oui, allez-y, il y a la traduction.
Bon, d'accord. Je remercie beaucoup Lisa de fait d'organiser cette conférence virtuelle, ce qui est très important pour nous. Et je crois bien, avec ce que nous avons comme la possibilité, nous allons vraiment un jour chercher à développer l'énergie renouvelable, surtout l'énergie solaire, pas seulement pour vous, mais pour nous les Africains, parce que tout ce qui se passe, c'est l'Afrique qui peut avoir des problèmes, parce que c'est là-bas, c'est ici qu'il y a trop de pauvreté. Donc, je voudrais qu'on se donne la main à travers l'ISA, l'Alliance solaire internationale, afin qu'on puisse développer ce type de projet aussi en Afrique. Parce que nous avons vu comment ça se passe. Allô? Allô? Bon, d'accord. Je disais que le projet, tout ce qu'on a suivi aujourd'hui, c'est très important. Mais le problème est que, est-ce qu'on a la possibilité de développer tout ce type de projet en Afrique? Parce que si vous développez en Europe, en Asie, mais on sait que c'est en Afrique qu'il y aura des problèmes, parce que c'est ici qu'il y a trop de pauvreté. Je voudrais qu'on trouve la solution pour l'Afrique. Sinon, tout ce qui est là comme proposition, comme des projets, c'est quelque chose qui est très important pour nous. Donc, je voudrais que vraiment que ça soit aussi une solution pour tous les pays africains. Tous les pays africains. Donc, je vous remercie beaucoup. Et nous sommes prêts toujours à participer à ce type de conférence. Comme on n'a pas la possibilité pour le moment à cause de Covid-19, de se réunir ensemble, mais avec des conférences virtuelles, je crois bien que c'est quelque chose de positif. Merci beaucoup. Je vous remercie.
Thank you, Your Excellency. With this, we move on to our next intervention. We have NFP Liberia with us. His Excellency, Mr. Stephen, would you like to please intervene? I would request His Excellency, Mr. Stephen from Liberia, to please intervene.
Excellency Stephen Potter. Kindly unmute you. Thank you.
Yes, good afternoon. Good afternoon. Actually, I was not asking a question. I only unmuted in error.
Thank you, Your Excellency. With your permission, I move forward. I would like to now invite His Excellency, Mr. Zakaria, NFP Niger. Sir, would you like to make an intervention? His Excellency, Mr. Zakaria. I invite His Excellency, Mr. Zakaria, NFP Niger, to please make an intervention. Moving forward, I would like to now invite His Excellency, Mr. Pauline, NFP Mali, to kindly intervene.
Bonjour tout le monde.
Your Excellency, we can
Vous
hear you.
m'entendez? Ok, merci tout simplement le Mali et remercier Lisa pour avoir organisé cette formation. Et les informations qu'on a pu recueillir pendant les différentes présentations nous seront très utiles. Mais nous souhaitons vraiment le développement de ce programme pour vraiment nous permettre de développer chez nous surtout le stockage d'énergie. Donc, c'est vraiment chez nous, là, c'est la priorité dans pratiquement tous nos projets. On a besoin vraiment du stockage d'énergie. Voilà, c'est tout ce que je voulais ajouter. Merci beaucoup.
Thank you, Your Excellency. I would now like to invite His Excellency Mr. Win from National Focal Point, Myanmar. Over to you, Mr. Win, please. His Excellency Mr. Win, I invite you to kindly make an intervention.
Mega, he has left.
All right, sir. Moving forward, I would now like to invite His Excellency Mr. Tawfiq from Yemen. Mr. Tawfiq, would you like to make an intervention, please? His Excellency Mr. Tawfiq from Yemen. Sir, would you like to make an intervention, please?
Excellency Tawfiq, would you like to unmute your mic and then speak? Move ahead, Mega.
Sure, sir. We thank all the national focal points of ISA member countries for joining us today. Moving on, we have the contact points of ISA member countries with us. I would like to invite the contact point, Ms. Radhika, Her Excellency Ms. Radhika from Australia.
Radhika also left.
Sure, sir. I would now like to invite His Excellency Mr. John Clark from Jamaica. Sir, would you like to make an intervention, please?
He also left.
Sir, I would now invite Mr. Kondi Mani, His Excellency Mr. Kondi Mani from Togo. Your Excellency, would you like to make an intervention, please?
Mega, he also left.
Sure, sir. We have with us His Excellency Mr. Desh Sahai from Tonga. Sir, the floor is yours, please.
Good evening, everybody. I would like to thank the Director General ISA, Senior Advisor, Advisor Mr. Mahapatra, Mr. Gyani, and illustrious speakers and organizers for this yet another excellent webinar on an important subject that we have overrun the time. Every time we overrun by more than an hour shows the keen interest and usefulness of these webinars. And with this, I look forward to the continued assistance which Tonga is receiving. We have already submitted our proposal for this grant funds, project, and we are on way for the water solar pumps. Thank you very much, everybody. Bye.
Thank you, Your Excellency. I would now like to invite Mr. Arun Mishra, Senior Advisor, International Solar Alliance, to kindly present the closing remarks.
Thank you, Mega. Your Excellencies and honorable speakers, I know that you overshot the time a little bit, and but I must say that the presentations have been extremely useful and very, very detailed. The many takeaways from these presentations for our member countries. We got a glimpse of what the future is going to be from Mr. Marcel from Siemens. Mr. Mahapatra told us that the total number of electric vehicles in 2019 in the globe is about 7.2 million. But also Mr. Marcel told us that by 2030, Europe alone will have 31 million electric vehicles from the current level of 2 million. So you can imagine the kind of future that you're looking at. So the battery, the charging stations will not be requiring kilowatts of power, but it shall be requiring megawatts of power. We are also told by one of our very honorable speakers that the transportation itself will require almost like 19 gigawatts of power, as opposed to the 17 gigawatts of power, as opposed to 19 gigawatts of power by the PV systems, electric systems. That shows the kind of future that you're looking at. And it helps that transportation catering to almost like 18% of the total pollution levels will come down substantially. But that's a huge new area that everyone is looking at. And that's why this seminar is so important. But is it expensive? Is it going to, it's not doable. Is it beyond our capacities? And we heard Mr. Rahul. He came out with very good explanations. You know, I will combine Rahulji's presentation with Mr. Bhatt's presentation. You know, Mr. Bhatt gave us an example of India, and wherein he said 98% of the total number of vehicles that are being deployed in India are of small capacity. Only 2% are of large capacity. Even though I have doubts about whether 30 to 60% of the population use public transport, but I will not question that. But if we take that 98% of the population, the transport capacity that India has created, a small scale four-wheelers, mostly two-wheelers, three-wheelers, rickshaws, that is true of the rest of the world. It's when at least our member countries, we don't have too many heavy duty vehicles though in those countries. So if India can manage with about 98% of these vehicles, I suppose most of the member countries can also do that. And that's where Mr. Rahul's presentation becomes very useful. He came out with those combinations in which battery plus electricity, RE generation combined together is still affordable. So far, most of the people have always thought that, you know, battery, when the storage is combined with electric generation, even if it is RE generation, it becomes prohibitively expensive. It is not affordable. But Mr. Rahul's presentation made it very clear that it is affordable. If you do the right kind of combination, RE with battery storage can become, up to a certain level, becomes very affordable. So that is a big takeaway from this particular seminar. And then of course we heard Mr. Mohan from ESL. He gave us various ways in which an electric station and electric vehicle can be made available to the general public. And we also heard Mr. Rajneesh Goyal, who said that between Delhi to Chandigarh, how they are putting up electric charging stations, how they're deploying electric vehicles, and how at a capacity utilization of 33%, it becomes eminently viable. Of course, even in India, the capacity utilization highest has been about 20%. But of course, that's because the number of vehicles that we have is not very high. The ESL model also tells us that how at first, in the initial stages, there has to be country level interventions. Unless there is a country level intervention, unless there is a country level support, it cannot take off. But then, of course, the finest example were given by Mr. Rajendra Srivastava and Mr. Aditya Trivedi, how already on a commercial scale, up to a level of 100 megawatt storage capacity has already been created in various parts of the globe. Delhi itself has about 10 megawatts, and 100 megawatts is just eminently doable. And they also gave examples that 28 megawatts, up to 28 megawatts could be set up in places like Hawaii, standalone systems. So majority of our member countries will require these kind of interventions. We don't require 1,000 megawatt interventions. We don't require gigawatt level interventions. So for our requirements, the technology is already available. The proposition is already financially viable. That is what most of these presenters have clearly brought out. So I must thank all the presenters today for their excellent presentation. And Mr. Marcel has already agreed to share his presentation. Mr. Rahul has agreed to share his presentations. I am sure Mr. Amit Bhatt, who has prepared this presentation, and the other eminent speakers will have no objection sharing those presentations with all our member countries. They are great inputs that all of us can actually use. And so thank you very much for making this evening very, very useful. Yes, we agree that 3 hours is a little long period of time for anyone to maintain interest. The project team will definitely like to look into it. Just adding on presentations and allowing people to speak at length actually is not really very productive. It becomes counterproductive after some time. We have to think about it, what we do about it, and in future we'll make it very precise, we'll make it concise, and we'll make it in such a manner that people are here to listen to everyone. But yes, the very fact that there were not many questions shows how clear the presentations have been. Once again, thank you very much, all our honorable speakers, and congratulations to our project team for conducting an excellent. And thank you, Your Excellencies, for being with us all through. I can see Excellency Mr. Sahai. He's one of our great supporters who always is there with all of our programs. And people like your presence makes all the difference. It inspires people to work. Thank you very much. Thank you again.
Thank you, sir. Thank you, Senior Advisor, sir. Before I invite Ramesh Kumar, sir, Additional Director, International Solar Alliance, to present the vote of thanks, I would request Mahapatra, sir, to make a short intervention and take any suggestions from our esteemed guests, please.
Thank you, Megha. Excellency, I take the liberty for making this on-schedule intervention. This is to tell how encouraged we are with the level of participation that we had. We had 111 participants attending for the most of the 3 hours of the session. At one point of time, I was a little worried because more than 100, whether the system will support, but our technical team did a very good job. Nobody fell down or nobody was having a technical issue. A number of countries participated. And I must thank all the distinguished speakers who spoke at depth to the subject and enlightened us. The reason why I come in is that two things. As I said in my opening remarks, that we are planning as a sequel to today's webinar, another webinar on business models of solar charging. Models for ISM member country, what will be the solar charging models. So project team will be very grateful if any of you would like to make suggestions to us. You can email us or you can suggest us speakers who can speak about the different models which can be made on various of the ISM member countries, particularly LDCs and the small island developed states. So this is a request. We'll be looking forward from you, which will help us to plan this proposed webinar, which will be in the month of January, coinciding with this summit. This is the reason I want to say. And our next series of webinar will be next Thursday, that is on 10th of this month. That will be on solarization of the primary health center, the health sector ISA care facility. Thank you very much. We look forward to hearing from you.
Over to Ramesh, sir, please.
It was a very, very long 3 hours plus which we have consumed. So just to have I would like to have a formal vote of thanks to all the participants, the excellencies from our member countries, and all the other participants in the attendees mode who have joined this. And I would like to thank all the exciting presentations and thank each of the speakers who I contacted many of them personally, talked to them. And we wanted to get an idea of the various experiences. So we are thankful to you to cover the American experience, European experience, and Indian experience, which will the inputs come very handy whenever we are planning to go for the member countries to to start in these areas, because this is a very emerging and area where there is a the entire energy transition will happen with this kind of changes happening. So with that, I would like to thank each one of you, all the participants, all the speakers and excellencies, to make this very lively experience. And we would be in touch. We'll be continued to be in touch in these areas. So with that, I would like to formally close this webinar. Thank you.
Ramesh, sorry, I'm coming in. There are few questions which were raised we didn't get answer. So I'll suggest that those questions we should get it answered through emails to the participants who have raised it.
Sure. So
there
I
are
would
few questions which could not be answered. There's a query from one of the members.
Sure.
Please see to it that these questions get answered by our speakers and we respond to them through the mail.
Sure, sir. Sure. So I would personally email them those questions, and we would like to get the answers. So thank you for that cooperation. So I think with that, we are coming to an end of this webinar, which I would like to thank once again all the stakeholders of this webinar. Thank you.
Thank you, sir.
Thank you. Thank you, everyone.
Merci. Merci beaucoup.
Merci beaucoup. Thank you.
Hey, Ganesh, you are still there? I think Ganesh is left.
Yes, yes, I am there. Sir, Excellency.
Thank you very much. अब वो हमारा मेरे ख्याल कुछ चले गए अभी हैं लोग. Anyway,
है ना सर, महापात्रा साहब हैं, he is chair of the project committee.
हाँ जी, अच्छा.
टोंगा project, Mr. Ramesh is there.
महापात्रा साहब वो project हमारा आ गया. This has come, the demonstration project for solar water pumps. It has been sent already. I hope it is under process.
Yeah, it is under process.
And about our this 258 solar water pump projects, he had asked certain when this was sent to Tonga, he was needing some more clarifications on that, what we had discussed. So I had discussion with Mr. Litting and also a little bit with Mr. Shishir on the interest rates and also some other things. So I think we'll be submitting that soon also. He needs some clarification, for which I'll have a very small meeting between 3 or 4 of us this next week, so that we can move forward. And thank you very much again, for all the help. Thank you.
Let us know your convenience, we'll be always available.
Yeah, Excellency, we should have 2 separate meetings.
Haji.
One for the 258 pumps and one for the project, because one of the subject needs a lot of time. So sometimes,
the one which he has submitted, the demonstration project, have you had a time to look at it?
Yeah, that is the first priority thing we should go for.
No, but are there any clarifications needed from Tonga on that?
Rajesh Bharadwaj ji?
Because they have made quite a detailed presentation,
Yes, we have received the proposal and we discussed in the project group and we feel encouraged by the proposal. What we are proposing to have a bilateral meeting on the way forward. I think Mr. Rajesh Bharadwaj or the country coordinator will be in touch with you very quickly. Let's fast track the entire thing.
Okay. And about this 258 solar water pumps, then I'll have a discussion again with Gyaniji. And if need be, then we'll have another meeting before we have a meeting with the country, so that I can send it to them.
Yes, excellent. Because the routes are totally different for these 2 things.
I know.
Financing, and here it is a grant from
yes. So the grant, if the grant can be processed quickly, this will be great. Thank you. Thank you very much.
Excellency.
Thank you, Excellency.
Thank you all. Thank you.
Thank you.
Most grateful to ISA for all the help.
Thank you.
Thank you, Excellency.
Thank you, Excellency Tawfiq. Thank you, Excellency Maika, Excellency Potter, Excellency Zakari. and Mr. Pauline.
Thank you, Excellency Gyani. Gyani-ji.
Thank you.
Thank you.
Thank you, Rameshji. Thank you, Gyani-ji. Thank you,
Thank
Mahapatra Saab.
Thank you, Excellency.
Thank you, sir.
Thank you, Mr. Swadhin. Excellent job.
Thank you.
Thank you, sir.
Yeah, it was Mr. Kumar Swadhin who was the main person who
Yeah,
did a
it's
big
driving
task.
the entire thing. Yes.
So kudos to Mr. Kumar Swadhin.
Yes.
Yeah.
Swadhin is the main attraction, star attraction today.
Yes, yes.
Good. But Swadhin, the sequel is to be done.
Yes, sir.
Yeah, and
Swadhin,
I have just sent an invitation for the next event on 10th. I just sent to National Focal Point and I'm sending to Contact Point.
The 10th, I'm very sure we'll be doing a good job. We're all working, but I am a little, let's plan out this summit of January on which we have to do a sequel of what we did today, basically business models for the solar charging stations for ISA countries. We have to identify 8 manufacturers who have been working in these countries, and we have to find somebody who can speak on the business models. We can take the help of Philips and we can take help of...
So 2-3, I think, sir, 2-3 will come from Mr. Anil Srivastav, I hope, because he was...
Yeah, we should take all the help possible.
Yeah.
And Swadhin now has taken a lead. Of course, you are there.
Yeah, no. Swadhin is... The entire thing is done by Swadhin, sir. I'm just supporting from the outside.
Yeah. So Swadhin, I think, and we have requested everybody to give ideas. So let's work for the next, that 10th thing also very clear. But I know this primary health sector, I think all have worked hard. It will be going on very well, Mr. Sorle, Mr. Gavli, everybody. But why the important is primary health center? And the vaccine is a reality, and vaccine requires a dedicated, reliable cold chain. And this demonstration is going to be useful. And let's see how we can